Hi there. In this video, we're going to go over the mini practice exam that I created to help you pass the TExES 241 teacher certification exam so that you can teach computer science. Now, if you haven't already, I encourage you to follow the link in the description below and actually take this exam on your own. After you've done that, come along back to this video and let's go over the answers and make sure you fully understand each question and answer. All right, let's get to it. So question 1, this is talking about the expression 17 mod 5 plus 3 times 2. So this is really testing two concepts. One is, do you know your order of operations? So if you want some practice, go ahead and let's list the order of operations right now. So we have PIMDAS. This is a short acronym to help you remember the order of operations. And I'm writing it this way because of a specific reason I'll explain shortly. So P stands for parentheses, E exponent, M and D stand for multiplication, and A and S stands for addition and subtraction. I'll shorten it to add, subtract. So this is the order of operations. You do parentheses, exponents, multiplication, addition, subtraction. Multiplication, division, they are on the same level because they are the same level of priority. Now let's go ahead and apply this to this problem. So we see 17 mod 5 plus 3 times 2. Now this mod operation might be a little bit new to you, and let's go ahead and talk about that shortly. Okay. But we do see an operation that we can do right now, which is this 3 times 2. So let's go ahead and do 3 times 2. So that becomes 17 mod 5 plus 6. Now we have to understand what this mod is to fully complete this problem. You can think of mod as on the same level as multiplication and division. And it stands for modulus. Well, that's easy to remember. Both multiplication and modulus, or mod, are on the same level, so you know that it has the same priority as multiplication and division. So we now know that we need to do this modulus operation before we add. But what exactly is mod? Well, sometimes you might see mod shortened as 17, that's right up here, 17% 5 plus 6. And these two things are synonymous, the mod and the percent. Now, when we talk about mod, we are talking about finding the remainder. Now, for some of us, it may have been a while since we've talked about remainder, but the way I like to explain this to my students and to other teachers is think about when you first learned division in elementary school. You learned about this term called the remainder. And let's go ahead and try to remember what we did. So when we first learned division, we did something like this. And we went through it quite systematically. We asked ourselves, how many times does 5 go into 1? And we would say 0 times. So 0 times 5 is 0. And you bring that in the next place. And now we have 17. And now you ask yourself, well, how many times does 5 go into 17? That is 3 times. 3 times 5 is 15. And you get 2. Now, this is when most of us who have had higher than elementary school math start trying to complicate things. And we're like, well, we can add a decimal, we can add a zero, we can bring that down. No, you're thinking too hard, all right? I want you to think of elementary school math when you think of modulus. When you get to this point, what do? Well, you just say, this is the remainder, right? So then you bring it up, and you say remainder 2. So 17 divided by 5 back in elementary school was 3 remainder 2. And when you see that mod, you want to think of this remainder, okay? So let's continue solving the problem. Let's bring this over here, actually. So 17 mod 5 is 17 divided by 5, the remainder, which is 2. And then we get plus 6, and that will be 2 plus 6 is 8. Let's do that. Okay. All right, that's problem number 1. So make sure you know your order of operations and make sure you really know what mod is for this problem. All right, let's go on to question number 2. Question 2 asks, which of the following best describes the purpose of the requirements analysis phase of the software development lifecycle, or SDLC? So you'll see that this question doesn't really require you to do programming. The exam also requires you to understand other aspects of software engineering or computer programming. But oftentimes these questions, we can use context clues and elimination to help us answer this. So we are looking for something in the answers relating to requirements analysis. Just thinking about that, do you think that this should happen earlier or later when you're designing software? Well, probably earlier, right? You need to understand what is required of your software that you're going to write before you really start programming it. So probably looking for an answer choice that comes earlier. So let's look at A, writing pseudocode and selecting data structures for the solution. Well, maybe that's already starting programming, right? So that kind of seems a little after you're trying to determine what is required. B, identifying what the software must do and documenting software needs. Documenting stakeholder needs. Yeah, that kind of seems about right? You're trying to see what the stakeholders require of your program. Testing the completed software for syntax and runtime errors. Wow, this seems pretty late on. You're testing already completed software that you've programmed already. D, creating user documentation and training materials. Well, hopefully throughout your programming, you're trying to make sure the user knows how to use your software, and that whoever takes on your software afterwards can train others. But this also seems to be something that happens later on. So the most promising answer seems to be answer choice B. So the purpose of the requirements analysis phase is you're really trying to identify what the software must do and see what the stakeholder actually needs of your software before you start programming. Looking at each answer choice A describes the design phase. Answer choice C describes the testing phase, your testing software. And answer choice D kind of describes the deployment phase. You're deploying it for others to use, and you want to make sure the other users know how to use your software, which is why you create that documentation and training materials. So for this one, we would choose answer choice B. All right, let's go ahead and go on to the next one. This question says, a variable is declared as double x assigned 9.8, and the expression int x is evaluated. What value does the cast produce? So these are 2 lines of code, and sometimes it can be helpful to write it as a line of code followed by another line of code. You don't have to do this, but it could help. All right, so what exactly is happening? Let's look at the first line of code. On the left-hand side, you're creating a variable called x, and you're saying, hey, this is going to hold a double value. You might also know of double values as floats. Depending on the programming language, it really depends, but what you can know is that a double can hold a decimal value. Okay, that's the key. And inside, we're going to assign this variable x the value 9.8. So here we draw our variable x, and I draw my variables like a box, and inside the box, we have the value 9.8. Now, the next line of code line 2, we're going to go ahead and cast it as an int. Now, I don't know if you know integers, but if we just start listing some, 5, 6, 7, 2, -5, you'll notice that they don't have any decimals, right? So what we want to see is an answer choice that doesn't have any decimals. And that's what casting does. Casting gets rid of the decimal. So what we can see in our answers, we can immediately eliminate answer choice B. Now left with three other ones, 10, 9, and 0. So what does this casting actually do? Well, you can think of casting as chopping off the decimal. So if we have 9.8, then we chop off at the decimal and we get rid of everything to the, well, the right-hand side. So we would chop it off and we get rid of everything to the right-hand side. And that is my casted value of 9.8, which leaves me 9. The tricky thing is a lot of people think casting is rounding, which is why they think, oh, 9.8 becomes 10, but that's different. Casting just goes to the decimal point and chops off everything to the right of it. Another word for this is truncation or truncating. All right, that is question 3. All right, let's go ahead and go over question 4. A school network administrators are sending spam emails without users' knowledge. Investigation reveals that hidden software was installed through a phishing email attachment. Which type of malware is most likely responsible? And we're given 4 types of malware. Now, the good thing about these terms is typically the name matches what the term describes. So in this problem, we are told that software was installed through a phishing email attachment. So this kind of seems like it's sneaking through like some type of backdoor. It's being delivered through another vehicle. You're getting this email attachment, which you think is something related to what you need to do, right? You download a PDF or something, but then hidden within this attachment, it somehow installs hidden software. Let's look at the answer choices. A, is it ransomware? Well, the good thing about terms, once again, is there should be some type of ransom demanded in this problem if it was ransomware. Because there's no ransom, basically asking for money or something, this isn't ransomware. B, is this a Trojan? The best way to explain Trojan is to think of the Trojan War. And during the Trojan War, the Greeks gave a Trojan horse as a gift. However, hidden inside this Trojan horse were warriors, and when the Troy received the gift inside their city, the warriors went out and they, they conquered Troy essentially. So this kind of seems like it's describing what's happening here in that the investigation revealed, right? You think it's some type of legitimate thing, an email attachment. The city of Troy thought that the Greeks had sent a leftover gift or something, but then it was a trap. Now, let's look at C, a worm. The thing about worms in cybersecurity is that worms replicate. So that's the key thing. Because this investigation doesn't say anything about the software replicating, then we can eliminate C. And this is very similar to viruses as well. Worms, viruses, they are known for replicating. D, adware. Well, same thing with ransomware. If we don't see anything with a lot of ads, then this is not adware. So we eliminated A, there's no ransom. We eliminated C, this is not replicating. And we eliminated D, there's no ads being described. It must be B, Trojan. And that's question 4. All right, question 5. A teacher wants students to test whether a program correctly handles unexpected input, such as negative numbers and empty strings. Which testing strategy is the teacher emphasizing? And then the answers are about different testing types. Now, just looking at the question, they want to see, or they want to test if a program can handle unexpected input, such as negative numbers and empty strings. The truth of the matter is, coming to this test, you might not have studied every single term that you need to know. So oftentimes it could be good to practice using your context clues. So looking at this question, we want something that can test, or that is related to testing unexpected input. Looking at these answer choices, just looking at the words, which ones seem to follow along unexpected input? Well, answer choice C has that word input, right? And that's probably where I'd go too. I'd probably be looking at answer choice C and being like, unexpected input, invalid input. Yeah. So let's talk about the other terms briefly. Unit testing and integration testing, they're pretty, not similar, but they're pretty related. So when you test a unit, think of it like a cell. It is a small block. You're trying to test a single function, a single method with your unit testing. Integration testing is typically 2 or more. You're trying to integrate something with something else. It could be 2 pieces of code, making sure they work together. You could be trying to integrate a smaller piece of code with your main block of code, making sure that smaller code works with the main block of code. That's integration testing. Regression testing is making sure your new features that you just made don't break earlier code or earlier features. So you test to make sure that the new code does not break earlier code. The regression, you're regressing through time the changes that you've made, making sure that the new changes don't affect or don't harm the old code. In a boundary and invalid input testing, you're trying to basically validate or test for extreme or unlikely or prohibited inputs. For example, when taking the square root of something, you want to make sure that your program handles, hey, what if the user inputs a negative number? Or if your program's supposed to, return a string flipped around, mirrored. Well, what if they input no string, right? An empty string. So that is boundary and invalid input testing. So this question, again, if you didn't know the terms, it could be helpful to just practice using your good test taking strategies and make sure you look for those similarities in the keywords. Next, question 5. All right, question 6. So here we have, we're assigning values to variables. We have that mod once again that we saw earlier in question 1. And we have an if conditional with an else following it. Let's go ahead and go through this line by line. I'll go ahead and number them. 1, 2, 3, 4, 5, 6, 7. All right, line 1, what are we doing? We are going to go ahead and create a variable called x. And inside of x, we are assigning the variable x, 15. Line 2, we create a variable called y, and we are assigning it a value of 4. And now on line 3, we're going to ask ourselves, is x mod y greater than 2? I like to always mentally replace the word if with is, and I just ask, is whatever's in the parentheses true or false? Well, what is x mod y? X mod y is the same thing as x is 15. We can represent mod with percent sign, and y is 4. So what is 15 mod 4? Well, let's go ahead and do our elementary school division. 0, 3. So it is this remainder. So 15 mod 4 is 3. So what you can do mentally, and I'm going to show you right here, I'm going to go ahead and replace that with a 3, because that's the result, right? 15 mod 4 is 3. And if you need an explanation of what mod is, go back to question 1 and explain how we get this mod thing in question 1. So is 3 mod 2, is 3 greater than 2? True or false? It's true, right? So this is true. And if an if condition is true, that means you go inside the if and you do what is inside, which is we do x minus y. So x minus y is 15 minus 4, which is 11. And we assign 11 to x now. So x is now 11. Now the question asks, what is the value of x after the code segment executes? And we see that, well, x is now 11. And we have that here. All right, so question 6 really tested. Do you know your mod? Do you know how if and else works? So make sure you really understand that before going to this exam. That's question 6. Question 7. Which of the following best describes the purpose of a local area network? Is it A, connecting computers across multiple countries using satellite links? B, connecting devices within a limited geographic area such as a building? C, providing wireless internet access to mobile devices across a city? Or D, routing packets between the public internet and private networks? I don't know if you remember this, but there was a time when we had what are called LAN parties. And basically, you get together with friends, bring your game console in the same building, you hook them up all together, and you play on your game consoles all together, in the same building. And so that's what I always think of when I try to think of LAN. Another way to think of LAN, or a local area network, is think of your home as having or being a LAN. So the best answer choice that matches those two descriptions are B, connecting devices within a limited geographic area such as a building. Let's go ahead and do blue. Let's look at A, connecting computers across multiple countries using satellite links. I would say that's more what we call a WAN, W-A-N, a wide area network. Providing wireless internet access to mobile devices across a single city, well, we call that metropolitan area network, or MAN, M-A-N. And routing packets between the public internet and private networks, I don't think that really is any of the mm, PAN, LAN, MAN, WAN. I think that would be a different term altogether. The other term that's not mentioned here is PAN, which is PAN, Personal Area Network. And I like to think of it as the things that you, one person, would use. So Bluetooth, Bluetooth headphones, things like that. All right, and that is question number 7. All right, question number 8. Once again, I see lines of code. I'm going to go ahead and number them to better talk about this question. So one of my sayings is code goes top to bottom. Let's go ahead and start top to bottom. On line 1, we are creating a data structure called an array. And we have a variable called data. And inside of data, I'm going to go ahead and show you this notation. But because we're putting a data structure inside of here, we actually put a reference, a memory address. And I'm just going to make up a memory address. I typically just, and this is going to go ahead and actually point my data. And I have 3, 7, 1, 9, 2, oh, too small, 8. And now I have another variable called target. And it has a value of 9. And on line 3, I have another variable position, which has -1. And now we have our for loop. Let's go ahead and talk about how a for loop works. You're going to notice inside the for loop, we have 2 semicolons here and there. So those 2 semicolons break up the for loop header, that's what I call it, into 3 parts. Here, here, and here. Those are the 3 parts. Now, the way you read a for loop header is like so. The first thing you do when you approach a for loop is you always go here first. Okay. So what we're doing is we're creating a variable called I, and it has the value of 0. So I'm going to go ahead and let's have some room here. We're in the for loop. Okay, and I have I has the value of 0. The next place you go in a for loop is you go to the condition, which is in the middle. That's where you always go. And you have to ask yourself, is I less than data.length? Well, I is currently 0, but what is data.length? Well, if we look at data, which is right here, data is pointing to an array. And what is the length of that array? Well, the length is 1, 2, 3, 4, 5, 6. So I'm just going to write right here that data dot length equals 6. You don't have to do that, but it can be helpful to just make sure I know data length is 6. So is 0 less than 6? Yes. And if the condition is true, this is where a lot of people get tripped up. They think they go to the very next place in the for loop header, but that's not correct. If the condition is true, you go inside. Okay. So that is inside the for loop. So let's go ahead and write that note. If condition is true, go inside the for loop. And I know what is inside the for loop I know it's between lines 4 and 8 because the word for is the start of the for loop, and the words end for are the end of the for loop. So now that I'm inside the for loop, I need to do the if condition on line 5. You ask yourself, is the data at I equal to the target? So we need to talk about index values now. So the index, that's index 0, 1, 2, 3, 4, 5. We start indexing at 0. My best explanation for this is it has to do with how memory is stored in a range and how the calculations work, but that's really beyond the scope of this. If you think it'd be something you're interested in, let me know, and I'll be sure to make a video on that at another time. But we see that we start at index 0, and we're saying, what is data 0? Right? We replace the I with the value inside I, so we're asking ourselves, what is data 0? Well, that is a value of 3. Right? We see that at data 0, there is a value of 3 there. So is 3 equal to my target value? And target has a value of 9. Is 3 equivalent to 9? No. And because the if condition is false, we do not go inside the if. We don't do line 6. We go immediately to line 7, the end of the if. Now we go to line 8, but we're not done yet. The only time a for loop finishes is when the condition is false, which is the condition on line 2, the for loop condition. So the if condition was false on line 5, we skip line 6, we go to line 7, we then go to line 8, we're not done, we loop back around, and now we do this part right here. We call that the increment, the decrement, basically the change that should happen. And now we add 1 to I, and I is now 0 plus 1, which is 1. Now, after that, after you go to the change, you now go back to the condition. And we ask ourselves, this is now 5, is 1 less than 6? Is I less than data length? Is 1 less than 6? That's true. So because the condition is true for the for loop, you go inside the for loop, and we're back at line 5. Okay. So we are now here. And you ask yourself, is data at index I equal to my target value? Well, what is data at I, or data at 1? If we look at our array, that is the value of 7. So you ask yourself, is 7 equal to target, which is 9? No, 7 is not equal to 9. So because the if condition is false, you do not go inside the if, which is line 6. You then go to line 7, to the end of your if, you go to line 8, which is the end of your for loop, but then you loop back up, and we are now once again at this change step, increment and decrement. So I is now I plus 1, 1 plus 1 is 2. Okay. And then after that, we go once again to the condition. And you ask yourself, is 2 less than 6? True. Because the condition is true, you go inside here. Okay, so you see how it's looping over and over. This is why it's called a for loop. I'm still going to explain each step, but I might move a little bit faster. If you are still having a little bit of trouble understanding how a for loop works, rewind a bit and work through, or let's work through together the earlier parts when I was 0 and 1, and I worked a little bit slower. So we are on line 5 now, and we're asking ourselves if data2, which is the value of 1, is that equal to 9? That is false. 1 is not equal to 9. So we go to the end if on line 7, we go to the end for on line 8, and then we loop all the way back up to the change. And so I is now 3. And then after we do the change, we go to the condition. Then we ask ourselves, is 3 less than 6? True. Because the condition is true, you go inside the for loop. And you ask yourself, is the data at I, which is data at 3, which should be here, is the data at index 3, which is 9, is that equal to the target value, which is 9? And yeah, 9 is equal to 9. So because that's true, you go to line 6, you go inside the if condition, and now we see that we assign to position the value of I. So I'm going to assign 3 because I currently has the value of 3. We go to line 7, we go to line 8, then we loop back up. So now here. Remember, code goes top to bottom. But now we're looping back up, right? So I is now I plus 1. So I is now 4. We then go to the condition. Is 4 less than 6? That's true. We go inside the for loop because the condition is true. So we go to line 5. And you ask yourself, is the data at I, which is the data at 4, which is a 2, is 2 equal to 9? False. So because if condition is false, you do not go inside the if condition, you skip it, you go to the end of it on line 7, you go to the next line of code on line 8, you loop back up. And you now increment I is now 5. You then go to the condition, and you ask yourself, is I, which is 5, less than 6? That's true, condition is true. Because the for loop condition is true, you go inside the for loop, and now you're back on line 5. And you ask yourself, is the data at I? And that is here. Is the data at index 5, which is 8. Is that equal to 9? And that's false. 8 is not equal to 9. And so because the if condition is false, you do not go to line 6 because that's inside the if. And then you go to line 7, you go to line 8, you loop back up. And you increment. We add 1 to I. After the increment, we go here and you ask yourself, is I less than data length? Is 6 less than 6? False, right? 6 is equal to 6. 6 is not less than 6. So because the for loop condition is false, you do not go inside the for loop. You go to line 8 and you're done with the for loop. Okay. So the question is asking, what is the value of POS position after the code executes? And we see it has a value right here of 3. Wow, that took a long time. So question 8 really made sure that you understood, do you know how for loop works? Do you know how an array works and how the indices work as well? So before the exam, make sure you really are comfortable with those two concepts. I showed you step by step how I'd go through this, but once you get more comfortable, there are definitely a lot faster ways to approach this problem. If you're interested in those ways, if you want me to show you this again, but faster, let me know in the comments and I'll be happy to make another video about that. All right, that was question number 8. All right, question number 9. A computer science teacher uses the term abstraction when describing how to manage complexity in a large program. Which of the following best illustrates this concept? So we're looking about what is this idea of abstraction, and it has something to do with managing complexity. So let's look at A. Rewriting all code in a single function to reduce file size. Well, let's think about it a little bit. If we have multiple functions and each function does something specific, but then we combine it all into one single function, would that be easier as a programmer or harder as a programmer to maintain? Well, that would actually be quite harder to maintain the program if you had to combine all separate functions into a single function. True, it might reduce file size negligibly, but it would make it massively more difficult to maintain your code, and it would be harder to manage complexity in a larger program. So definitely not A. B. Hiding implementation details behind a well-defined interface. Well, if I, as a programmer, am working with a lot of code, and I don't need to know exactly how a single function works, I just need to know how to use it through a well-defined interface. Yeah, that sounds like it could be helpful. Adding comments to every line of code for documentation. Yeah, I think that might be helpful, right? If there's a lot of code, I can briefly glance at the comments to catch myself up to speed on how this function or code works. That could be nice also. D, using shorter variable names to improve execution speed. Um, if it does improve execution speed, it'd be very, very negligible. In fact, um, using shorter variable names, you should use descriptive variable names so that you as a programmer and anyone that is working with you can quickly understand the purpose of that variable. So definitely not D, because shorter variable names actually increases complexity because you're trying to guess what the variable is supposed to hold or do or the purpose of it. So now we're left with two concepts, B and C, and they both seem to help manage complexity. But we're concerned with the term abstraction. The way I like to describe abstraction to my students is imagine you're driving a car, and I don't know how a car works internally. My older sister, she knows more about cars than I do, but I just know I drive the wheel, I turn the wheel, I have my automatic drive, neutral, reverse, park, and how to turn the windshield wipers. I don't know the internal combustion temperature of the engine. I don't know the speed of the pistons. I don't know horsepower. I don't know any of that. But even despite that, I can still drive a car. Isn't that crazy? Imagine having to know how everything works in a car so that you could drive it. So all of that stuff is abstracted away from you. It's hidden away. The finer details of how a car actually runs, works, it's hidden away from you, and you have a pretty standard interface of how to operate a car. Most every car has the same type of steering wheel, same, if you drive automatic, same type of automatic gear shifting. It's pretty standardized, it's pretty nice. Another analogy I use to describe this idea of abstraction is imagine using a computer, which you're probably using right now to watch this video. Do you know the frequency of your clock in your computer? Do you know the voltage that each portion of your computer is getting right now? Do you know the number of cores? No, you don't, right? And all of that stuff is hidden away from you. Imagine if you had to know how every single little part of your computer worked in order to use your computer. I think most of us would still be back in the Stone or Bronze Age if that was true. So the idea of abstraction is hiding away those inner workings so that you can focus on a larger picture idea. So the best answer choice that goes along with that is answer choice B, hiding the implementation details behind a well-defined interface. For computer, the well-defined interface is a keyboard and a mouse. You use that to use any computer really, right? For a car, it'd be the driver pedal, the brake pedal, the wheel, the gear shift. You can use that to drive pretty much any type of car. So that is how abstraction can help manage complexity in real life and in a program. See, adding comments to every line of code for documentation, that is just a good programming practice, but it's not necessarily abstraction. All right, that is question number 9. Hello, question number 10. So in this question, we have a truth table. We have a column P, we have a column Q, and we have a result column. And we are asked which logical expression produces the result column. Now, let's say you can't tell just by looking at it which one it is. My best recommendation is make sure you know how to do a truth table. Let's go ahead and do A. Okay, so we have P, we have Q. I'm going to do this. And A is P and Q. So let's go ahead and do my true, true, false, false. Now, the way I like to describe and is I think of my mom as kind of this and. When I was a kid growing up, I had to make sure I did my homework and I completed my chores, and then I would be able to play games. So let's say I've done my homework but not done my chores. Can I play games? No. What if I didn't do my homework yet and I did not do my chores? Can I play games? No. Right? I have to complete both of them in order to play games. So I have to both P, complete my homework, and Q, complete my chores, and then I can play games. If I do only one of them, let's say complete my homework, P, that's true, but I don't do my chores, then I cannot play games. So for an and to be true, both of the things have to be true. Now, for an or, which is B, I like to think of or as my dad when I was growing up. My dad was a little bit more lenient on certain things, and he was like, if you do at least one of them, then you can, go play games. So if I've done both of them, awesome, go play games. I've done one of them, go play games. I haven't done either, you gotta do at least one to play games. So for an or to be true, at least one of those things have to be true. Now for C and D, I'm going to borrow a little bit from A and B. Copy that. Let's do this over here. So we can break this problem up into separate parts. We already have P and Q. What C is doing is just knotting that result. I like to think of not as like your best sarcastic friend. They're like, you're so smart, not, or something like that, you know? But the idea is they mean the opposite of what they say. So I am going to not P and Q. I'm going to not P and Q. But good thing is we already have P and Q over here. So I'm just going to go to that column and do the opposite of whatever that column says. So true, it's false, false, true, false, true, false, true. And that is not P and Q. You can do the same thing with or. So if you look at D, D is just a not of B. Right? So I'm going to go ahead and not that column. So not true is false, not true is false, not true is false, not false is true. Oh, I should probably do it in red like I did the other one. And now you're just asking yourself, well, which of these A, B, C, D truth columns has the same thing as the result right here? And we see that C has the same truth table as the result. So it is answer choice C. So for question 10, make sure you know your and, ors, and nots. I have my own analogies to help me remember what is what. Create your own. And also, a helpful tool to be able to answer this question is being able to draw that truth table yourself. All right, that is question 10. All right, let's go ahead and go on to question 11. So question 11 asks, which of the following data types would be most appropriate for storing a student's grade point average? And the example they give is 3.75. So the key thing for this question is grade point averages are numbers and they might have a decimal point. So which of these variable data types can store a number that might be a decimal number? Well, let's look at A. A says int. Well, int is short for integers, and if we think of all the integers we know, they don't have decimal values, right? So we can cross off A. B, float. Now, float is can store decimal values, but let's suppose that you didn't know what float could store. Well, we could use process of elimination to get to the other ones. C, char. That's short for character. So character would be letter A, letter B. Those are characters, maybe an exclamation mark. So that is not a decimal value, so it would not be character. D, Boolean. Now, Boolean is either true or false. So you can't store a number, let alone a decimal. So it is going to be B float. Now, again, suppose you didn't know what a float was. Well, then you had to put on your best test-taking strategy hat and use process of elimination to get rid of the other ones until you can come to float. All right, that is question number 11. All right, let's go to question 12. A software developer is asked to break a complex problem into smaller, manageable subproblems, then solve each subproblem independently before combining the solutions. Which design strategy is being described? So, to put it into my own words, it sounds like we have a big overarching problem that might be quite complicated to think about, and we're trying to make it manageable by breaking it into discrete, smaller problems that I can probably attempt to do. So, which design strategy is being described? Now, there are 4 terms that you should be familiar with before entering the exam. black box testing. Think of it like you have a black box. You don't know what goes on in this box. You can put things in, input, and you observe the output, but you don't know what actually happens in the box. So this is basically testing software based only on inputs and what you see coming out, the outputs, without looking inside the code at all. That doesn't really describe what this problem is talking about. B, object-oriented design. So think of this as programming or design focused around objects. This is a type of methodology that structures a software program around objects that combines data and the behavior into object itself. Once again, this doesn't really quite address what this problem is asking for, so it would not be B. C, top-down design with stepwise refinement. So top-down design, just looking at those words, seems like you start from the top, you keep designing downwards, and you refine as you go. So the way you can think about this, it's a pretty high-level strategy. You start high level, and you keep breaking it down into smaller problems until you reach something that you can solve. And that sounds possible, right? If you didn't know the exact terminology, the exact definition. Or D, rapid prototyping. So rapid prototyping, you do something fast. And what exactly is a prototype? Well, a prototype is something you build beforehand, right? Before you invest a lot of money, invest a lot of time into making something that might work. And it's something you want to test before you get to the final step. So rapid prototyping. Well, out of all of these answer choices, just using what I know about each term, C seems like the best answer. Now for question number 12, I do encourage you to put these terminologies and the definitions on your vocab list and make sure you understand them. But once again, suppose you approach this question on a test and, oh, I forgot what each term meant. Well, that is when you start looking at the words black box testing, object-oriented design, top-down design, rapid prototyping, and you try to make connections with what the definition actually is. It's okay if you don't memorize the exact definition, but you should be able to, from the words, determine what is supposed to happen. All right, and that is question number 12. All right, question number 13. So once again, if you look at the code, we're given a for loop. And we went over how to go through a for loop in question number 8. So if you want to see step by step, go ahead and go to number 8. I'm going to show a different kind of way to keep track of values in a for loop. So here we have int total, it's line 1, 2, 3, 4. And we have a variable called total, and it has the value of 0. And then we go into the for loop. So I'm going to go ahead and create the values of k and total. So k is assigned the value of 1. And I check, is k less than or equal to 4? Now, you can write this in your table, you don't have to, but I find that for a lot of teachers that I've helped with this concept, it helps them when they actually just write all the steps in the table. So is 1 less than 4? And you check, it is less than 4. And then what happens after the condition is true? Well, if the condition is true, you go into the for loop. So we are now on line 3. And now we have total again. And once again, I'm doing this because a lot of teachers and students have found it to be helpful to write all the steps in the table. So total is now total plus k times 2. So k times 2, 1 times 2 is 2. Total was 0. So 0 plus 2. 0 plus, I'll just write all the steps. 1 times 2 equals 2. All right, I just finished line 3. I reached line 4, but because the condition of the for loop was not false, I go back to the top, the header, and I go to the increment. K is k plus 1. So k is k plus 1. So k is now 2. And again, if you want to get rid of that column, you don't need that column. I just find it helpful for teachers. So it goes all the way there. All right, now I check once again. Is k less than or equal to 4? That is true. And so total is now total plus k times 2, which is 2 plus k, which is 2 times 2, which is 4, 6. I reach line 4. I go to the top. So k is now 3. Bring that over. Is 3 less than or equal to 4? That's true. So because the condition is true, I go into the for loop. Total is now total plus k times 2. So total is 6 plus k, which is 3 times 2, which is 12. I reach the end of for loop on line 4. I loop back up to k is k plus 1. So k is now 4. K is now 4. And then I once again reach the condition, is 4 less than or equal to 4? That is true. So I go into the for loop, and I'm on line 3. I do total is now total plus k times 2. So total was 12 plus k, which is 4, times 2. That's 820. And now I go to the increment. K is now 5. And now I check. Is 5 less than or equal to 4? That is false. So because the condition is false, I exit the for loop and I'm done. So what is the value of total after the loop finishes? It is that 20 right there. And I should erase this. It is that 20 value over there. So once again, make sure you really know how your loops work, your while loops, for loops, do while, and repeat until loops work for this exam. All right, that was question number 13. All right, question 14. A teacher asks students to use a spreadsheet to create a model that simulates population growth under different conditions and then analyze the results. This activity most directly supports which technology application's objective? So it seems like they're using spreadsheets and they're creating a model for population growth and to analyze the results of that. So A, is this an example of using productivity tools to format documents? Well, they're not really formatting anything, right? They're using the spreadsheet to create a model, to model something. I wouldn't say it's formatting. B, using simulations and models to explore complex concepts and develop hypotheses. Isn't that what this problem is asking about, right? They're using a spreadsheet to create a model that simulates population growth. So, I mean, we can't really do that. Well, anyways, B seems like it more closely aligns with what this problem is asking. C, evaluating the accuracy of information obtained from the internet. Once again, this question isn't really saying anything about where this information is obtained. It doesn't talk about the internet at all. So I think C probably isn't the right answer. And D, understanding the historical impact of technology on society. It is true that we are using technology to understand something about society, right? Population growth. But to say that we're trying to use a spreadsheet to understand the historical impact, that's kind of taking it a little bit too far. So out of all these answer choices, B would be the best answer. Once again, for these types of test questions, A lot of it is just coming down to reading, and you'll see that on the actual exam. A lot of it isn't actual programming. It's just, can you read this? Can you understand what it's asking? And can you eliminate answer choices and pick the one that most closely aligns? That's question 14. All right, question 15. So question 15 says, a sorted array contains the values 2, 5, 8, 11, 14, 17, 20, and 23. And it says a binary search is performed to find the value 17. How many comparisons are needed to locate it? Okay, so key things are we're doing a binary search on a sorted array, and the value we're trying to find is 17. And we're looking for how many comparisons we need. So let's look at this array right now. I'm going to go ahead and draw it. Here we go. 2, 5, 8, 11, 14, 17, 20, 23. So for binary search, you want to find the middle value and keep finding that middle value. So question, what is the middle value of this array? Well, it seems like there are two values, right? 11 or 14. Now, I don't know if you remember in middle school when you're trying to find the average of the two middle numbers, don't you add them up and divide? But not in this case, okay? In this case, there's actually a clever way of finding the middle value. So it is the left, I'll say left index plus right index divided by 2. What do I mean by that? Well, here we have 0, 1, 2, 3, 4, 5, 6, 7. And when I say the left index, I mean the left index of where I'm looking. Where could the value possibly be? So here is going to be my left index. And where would be my right index? Well, this would be my right index. Because my value is 17, the value I'm trying to look for inside this array could be anywhere in this array, from the first index, which is index 0, to the last index, which is the index 7, the last index in the array. So looking at that, we do left plus right divided by 2. So that would be 0 plus 7 divided by 2, which is 3, right? It is 3. Now, wait, you might be asking, Mr. Wong, isn't it 3.5? But remember, for programming, when we do integer division, integer 7 divided by integer 2, the result also is going to be an integer. So yeah, we both know it'll be 3.5, but because it must be an integer, we truncate it, we chop off everything to the right of the decimal, and it's only 3. That means this is going to be the first number I look at. Okay. So then you ask yourself, well, is that the value I'm looking for? Is that 17? No, it's not, right? Is that number smaller or larger than 17? Well, that value 11 is actually smaller. This value right here is actually smaller than 17. So what does that tell you? Well, because this is a sorted array, I know that 17 must be on the right-hand side of this 11. So that means I don't need to look at any of these values, because the value I'm looking for, this 17, is greater than 11. I know that I can just look at the right side of that index. So now we're back at step 1. And let me go ahead and write down step 2. Compare value at the index. So we compared 11 is less than 17. Look right. Okay. So now we have to, once again, determine where to look. And notice how I eliminated half of it. Well, what is my new search space that I'm going to be looking through? It's going to be indexes 4, 5, 6, and 7, right? So when I do my find the middle of array, step 1, well, I need a left index plus a right index divided by 2. My left index is going to be the leftmost location in the portion of the array I'm searching through. That's going to be 4. Because I eliminated indexes 0, 1, 2, 3. 17 cannot be there because 17 is larger than 11. And I know this is a sorted array, meaning the numbers go in ascending order in this case. So I have my left index, I have my right index. Let's go ahead and do the calculation once again. I have 4 plus 7 divided by 2, which is 11 divided by 2, which is 5. So I'm going to go ahead and look at index 5. Okay. So index 5, we're going to look here. That is my index. And I compare the value. I'm on step 2 now. I compare the value at that index. So is 17, 17. And it is the value I'm looking for, right? So that is good. They're equal. I'm good. And the question is asking how many comparisons did we need to locate it? Basically, how many times did we do step 2? Well, we compared first the 11, and then we compared the 17, right? So this is the first comparison, second comparison. So that was 2 comparisons. So for these types of questions where you're doing a binary search, make sure you understand how that middle search term is calculated. How do you find what term is considered the middle? That would be our step 1 right here. Then make sure you understand what is being compared. You're comparing the value at that index. And then let me go ahead and write step 3. Either you found it, great job, you found your value, or you didn't find it and you eliminate half. Just like we eliminated half of the search space by eliminating 0, 1, 2, 3, those indices. All right, that was question 15. All right, question 16. A student's program compiles without errors, but it produces incorrect output. The student discovers that a loop counter is incrementing by 2 instead of 1. What type of error is this? Let's go ahead and look at each answer choice. A, is it a syntax error? So an example of a syntax error would be missing parentheses or missing a semicolon. That's not what this program is talking about. B, runtime error. So a runtime error would crash the program while the program was actually running. But it seems like this program is able to run. It's just that it's incrementing by the wrong value. So it's not a runtime error. C, a logic error. Yes, this would be an example of a logic error because the logic is wrong. The person or the program is supposed to increment by 2, it's supposed to increment by 1, but instead it's incrementing by 2. Those are considered logic errors. D, compilation error. So a syntax error is a type of compilation error. But basically, there's 2 parts to running, for example, a Java program. You first compile the program, and then after the program compiles, you can run the program. But as we see in the question 16, it says a student's program compiles without errors. That means it's not the compilation error. All right, so the answer is C, a logic error. Once again, a syntax error, semicolons, parentheses, and syntax errors are typically types of compilation errors. It's not B because runtime errors would cause the program to actually crash. All right, that's question 16. All right, question 17. So here we have two for loops, one inside the other for loop, and we have this interesting notation that you might come across at times. So just to help ourselves, let's go ahead and rewrite this into a more familiar pattern. So for I is 1, 2, 3. This is the same thing as for int I is less than equal to 3, I plus plus, or let's just do I is I plus 1. Similarly, the j would be int j 2. J is j plus 1. And then we want to print the result of I times j in 4 in 4. So the two are the same thing, the one on the left-hand side, the one on the right-hand side, but you should be able to go between the two. The left-hand side can be easier. So just looking at it, how many times does the outer for loop, the I loop, run? How many times does the outer for loop run? This is I. And how many times does the inner for loop run? That would be j. My i's and j's are looking a little similar. Now, you could spend quite a lot of time tracing these for loops, but again, this is a time test, so we do want to practice some of those test-taking strategies. Well, the outer loop is going to run 3 times for when I is 1, 2, and 3. So that would be 3 times. The inner loop is going to run 2 times when j is 1, 2. So 2 times. Now, the question you need to ask yourself is this additive or multiplicative? Basically, for each time the outer loop runs, how many times does the inner loop run? Or is it that the outer loop runs 3 times and then the inner loop runs 2 times? Which one is it? Well, thankfully, we have our indentation to help us know that the inner for loop is inside the outer for loop. So if outer for loop runs 1 time, runs once, the inner loop runs 2 times because it runs for j is 1 and 2. So this would be multiplicative. So it's going to run I times j times, which is 6 times. So we can cross off A and D. Now we have to decide what is the last value that is printed. Well, ask yourself, what is the last value of I? And what is the last value of j? So I starts out as 1, and then it's 2, and then it's 3. j starts out as 1 and then it's 2. So the last value of I times j, which is what we're printing out right here, would be 3 times 2. Right? Because those are the last values that I and j are. So that would be 6 as well. So that would be answer choice B. That is question 17. All right, question 18. A robot uses the command move motor with a value, where a positive value moves that motor forward, and a negative value moves it backward, and 0 stops the motor. The robot has both a left motor and a right motor. Which of the following code segments would cause the robot to spin in place to the left? All right, so just imagining that we don't want the robot to move forward. We don't want it to move back. We don't want it to stay in place. We want it to turn left. This camera is a little mirrored, but just imagine it yourself with your left and right hand. What would it look like for the robot to turn left? Try to make that motion. Okay. So you should be imagining the right side of the robot going forward, and that's a good place to start. So we're going to look for the right side going forward. And looking at answer choice A, B, C, D, we see that all of them have the right side going forward except answer choice D. So we know this cannot be correct, right? Because that has the right side going backward. Now, we want it turning in place, spinning in place. So if the right side is going forward and we want it to turn in place, what must the left side be doing? Imagine it's just staying still. Imagine the left side is going forward. And now imagine the left side is going backward. Which one is it that we want in this case? Well, if the left side is going forward, then the robot is just going forward, right? Both the left and right motors are going forward. So it's not that one. Now we have to decide, do we want the left side to just stay as it is? Or do we want the left side to move backward? And the correct answer is we want the left side to move backward because we want the robot to spin in place. You can test this out yourself. If you don't have a motor or a robot with 2 motors, just imagine it with your hands. Imagine it spinning in place with your left hand moving backward and trying to do the same thing with your left hand just staying still and your right hand moving forward. All right, and hopefully that should help you realize that yes, the left motor must be moving backward while the right motor is moving forward for it to do for it to turn left in place. All right, that is question 18. Okay, question 19. Which of the following describes the difference between a compiled language and an interpreted language? Now, it might help to have some background and some knowledge of what languages are compiled versus interpreted. For example, Java is a compiled language. Before you actually can run the code, you must hit the compile button, and then something will happen, and then you can run the code. Interpreted language, an example is JavaScript. That is what powers the web, allows you to interact with things on the web. Yeah, so let's go ahead and look at the answer choices. A, compiled languages can only run on one operating system, while interpreted languages are cross-platform. Well, is Java, let's just use Java for example, can it only run on one operating system? Like, for example, Windows? But isn't Minecraft, which is based on Java, can't it run on multiple types of operating systems? So you see how we can use specific examples to help us kind of eliminate each answer choice. Interpreted language are cross-platform. That's true. JavaScript can run on your web browser on multiple platforms like Chrome, Mac, on iOS, right? Or Windows. But that first part, compiled languages can only run on one operating system. I think just knowing Java can run on multiple is a good counterexample. So A cannot be correct. B, a compiled language translates the entire source code to machine code before execution. An interpreted language translates and executes code line by line. Now, what if you didn't know anything about this? You might leave that up, right? You might just say, it could be right, might not be right. Let's leave it up for now. C, compiled languages do not use variables, while interpreted languages do. Once again, let's use our two examples, Java for compiled and JavaScript for interpreted. Does Java use variables? Yes. Does JavaScript use variables? Yes, they do as well. Var, let, those are some JavaScript variables. So we know C cannot be correct. D, an interpreted language is always faster than a compiled language because it skips the compilation step. Well, let's say you don't know anything about this either. So we might be left with just B and D. 50-50, right? Now, when you're left in this situation, you really should give it your best shot and answer it. Because if you get it wrong, or if you don't mark anything, there's no difference. So give it your best shot. Which one of these sounds more correct? Is it true that an interpreted language is always faster? Whenever you see an absolute, that's something you want to pay attention to and possibly be cautious about. Truth of the matter is, interpreted languages are typically slower than compiled languages because of skipping the compilation step, because they execute code line by line. So actually, interpreted languages are typically slower. And that is why D is wrong. So B, a compiled language translates the entire source code to machine code before execution. And that is true. When you hit the compile button in Java or for any C, C++, that is compiling the code to machine code. And an interpreted language translates and executes code line by line. That is also true as well. So B is the correct answer for this one. Once again, the TExES 241 exam, it's not just programming, it's not just software engineering type knowledge. It does require you to know some other aspects of computer science as well. All right, that was question 19. Okay, question 20. So consider the following pseudocode segment, and we are asked what is the value of total after the loop finishes. So once again, just to help us talk about it, I'm going to go ahead and put line numbers. And we start with count being 1. And total being 0. And I'm going to go ahead and draw it like this. There are many ways you can keep track of your variables and the values. I've shown you 2 methods already with the for loops. I'm going to show you a third way, I guess, for this problem. So I've done lines 1 and 2. I'm now on line 3. Is count less than equal to 100? I see count is 1. So yes, 1 is less than equal to 100. So I go to line 4 inside the while loop. And now I'm asking, is count mod 3 equal to 0? What is the remainder when I do 1 divided by 3? Well, 1 divided by 3 is 0. The remainder is 1. So, or that if condition is false. So now I go to count is count plus 1. Let me go ahead and change this up a little so that you can keep track better of what is happening. So count was 1. I asked is count less than equal to 100. I asked is count mod 3 equal to 0. Okay, so just to backtrack a little, count was 1, count is less than equal to 100, but count mod 3 is not equal to 0. So I go to line 7, count is now 2. I go to line 3. Is count less than equal to 100? It is. Is count mod 3 equal to 0? Nope. I go to line 7, count is now 3. Go to line 8, finish the while loop, go back to line 3. Is 3 less than equal to 100? It is. Because the while loop condition is true, I go inside the while loop, I go line 4. I ask, is count mod 3 equal to 0? It is. So now I do total is total plus 1 on line 5. Total is now going to be 1. And then I finish the if condition on line 6. I go to line 7. Count is now 4. I go to line 8. I'm at the end, so I loop back up. And now I ask myself, is 4 less than equal to 100? It is. Is 4 mod 3 equal to 0? It is not. So I don't go inside the if condition on line 5. I reach line 6. I reach line 7. Count is now 5. I reach line 8. I go back to line 3. I ask, is 5 less than equal to 100? It is. Then I go line 4. Is 5 mod 3 equal to 0? It's not. So I don't go inside the if. So I'm line 6, line 7. Count is now 6. Go to line 8. I loop back up. Is 6 less than equal to 100? It is. Go to line 4. Is count mod 3 equal to 0? 6 divided by 3 is 2. Remainder is 0. So that is true. Because the if condition is true, I go to line 5, and total is now total plus 1. 1 plus 1 is 2. Wow. Think about it for a second. Take a breather. How many times would I have to do this to draw this table out for this problem? How many times does that outer while loop run? Yeah, that while loop runs 100 times. I don't know about you, but I don't got time to do this 100 times. So at this point in the exam, I might just skip ahead to a further question, or I might start using some observational skills. Let's go ahead and observe what is happening. We are concerned with the value of total after the loop finishes. And the only thing that modifies total is line 5. So really we're asking ourselves, how many times does line 5 run? Okay, and line 5 runs as long as line 4, the if condition is true. So if we can somehow figure out all of the cases of when the if condition is true, then we can solve this problem. So we know that if condition is true when count mod 3, let me just draw the symbol, is 0. So what does that mean? Well, we see here and here, basically when I have a multiple of 3. So between, the question you need to ask is between 1, which is my starting value of count, and 100, which is my ending value of count, how many multiples of 3 are there? Oh, there's 3, 6, 9, 12, 15, 18, 21, 24, 27. You can count that if you want. Or you can just do 100 divided by 3. There are about 33 multiples of 3, right? 33 times 3 is 99. So from 3, 6, dot, 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 to 96, 99. So there's 33 of them. So that is going to get us our answer of B, 33. Once again, this is one of those questions where you really need to be familiar with how loops and conditionals work. And that way you're not just trying to constantly draw these tables out. Because although yes, you could solve this problem by fully completing this table, you're looking at 10, 20, 30 minutes of just doing that. And you don't have time for that. But because we were able to think outside the box and think a little bit above the problem and realize, oh, total is only updated when I have a multiple of 3. How many multiples of 3 do I have? That will be the answer. Okay? That is question number 20. All right, question number 21. A project manager creates a Gantt chart showing tasks, dependencies, deadlines, and assigned team members for a software project. Which phase of the SDLC, or software development lifecycle, does this activity most directly support? So once again, I highly encourage you to take a look at a graphic or a chart of what exactly the software development lifecycle is. But something I like is the different sections of this lifecycle kind of tell you what goes inside, goes on during that portion. So we are concerned with this part right here. Tasks, dependencies, deadlines, and assigning team members for a project. Is that requirements analysis? Well, it kind of sounds like they already know the requirements and they're getting together this team to work on the project, right? They already know tasks, and how do you know tasks if you don't know what is required? They have things that depend on it or it depends on. Again, that's really hard to do if you don't already have requirements down. So it's not A. Oh, is it B, design? Well, once again, it sounds like they've already designed or some type of thing they're working towards, right? They have tasks, dependencies, deadlines, and how can you have that if you haven't designed something to work towards? So it's not design. Is it project planning? It kind of sounds like project planning. I mean, you got this project manager right here that is trying to get together this team, this project, and tracking it with tasks, dependency, deadlines, and even assigning team members for it. Sounds like C is probably the right answer, but let's take a look at D. Is it maintenance? Well, maintenance means something has already been created and you just gotta maintain it. But based on question 21, it sounds like that they're currently working on building something. So it's not D. So C is the best answer choice here. Once again, for this question, take a look at the life cycle, the software development life cycle, and get to know each portion and what goes on each portion. That is question 21. All right, question 22. A teacher asks a student to write a function that takes 2 integers and returns the average as a decimal value. Which function signature and return type is most appropriate? So for this question, you need to know the different parts of a function. So right here, we have return type. Then we have the name of the function. And then we have the parameters. So looking at this, we want a function that takes in two integers. Let me go ahead and underline that in red. These are going to be our parameters. And it's going to return the average as a decimal value. So it's going to be the return type. So we should see decimal, name a function, and then in parentheses, int for the two integers. So which A, B, C, D matches that? Well, it's not A, because void means nothing. I always ask my students and teachers, what do you think of when you think of the void? And more often than not, they say nothingness. Yeah, so A is saying it returns nothing, but we want it to return a decimal, so it's not A. Is it B? Well, we want to return a decimal value and not an int, so it's not B. Is it C? Well, it's returning a double, and doubles are decimal values. We have the function name average, and it takes in two integers, which is what the problem asks. C sounds right. And just to finish it off, is it D? Well, no, because we want to return a decimal value and not a string. So that's question 22. Make sure you know the parts of a function header. All right, question 23. Which of the following is equivalent to not P or Q according to DeMorgan's laws? Now, if you know DeMorgan's law, this is really easy. The way it works is, let me just go ahead and shorthand it for you. This is not, let's go ahead and do, I'm going to, this is or, is and. So, not P or Q is equivalent. Same thing as not P and not Q. So if you know DeMorgan's law, this really helps. We can see that and choice B is the correct answer. But suppose you didn't know DeMorgan's law, what could you do? Well, you can do your truth table. So if I go ahead and draw my truth table for this, let's do P, let's do Q. And let's go ahead and do P or Q. And let's not that. Okay, so I have, and I'm just going to do shorthand of 0 being false, 1 being true. So both false, 1 true, and both true. P or Q, as long as 1 is true, or as long as 1 is 1, then the result is a 1. Now we not that, we get 1, 0, 0, 0. So this is what I'm looking for. This is not P or Q, which is this thing right here. I'm looking for an answer choice A, B, C, or D that matches that truth table. Let's go ahead and see each one. Let's look at A. Not P or not Q. So I'm just going to go ahead and do not P right here. I'm going to not Q right here. And then I'm going to or it, not P or not Q. So looking in the first column where P is, I'm going to not that. Looking in the second column where Q is, I'm going to not that. And now I'm just going to combine these two and OR them. So this would be 1, 1, 1, 0. So this is answer choice A. And you can see that it does not match what I circled in red earlier. So it cannot be answer choice A. Let's look at answer choice B. Let's confirm it. Not P and not Q. So this is answer choice B. I'm going to look at these two columns right here because they have the not P and the not Q. I'm going to add those two columns. 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 0, 0 and 0 is 0. So you see B matches. And we can finish up with C and D. Let's go ahead and do it. C is P and Q. So I'm looking at the far left columns of P and Q. On the very left, 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1. And once again, you can see that C does not match. Then we have not P or Q. So I'm going to be looking at these two. Let me go ahead and use a different color. I want to be looking at this column right here. Not P. And we'll be looking at this column right here, Q. So I have not P or Q. So not P is 1, Q is 0. I do an or. Not P is 1, Q is 1, or not P is 0, Q is 0, or not P is 0, Q is 1, or. So that would be D. So you can see, again, if you don't remember DeMorgan's law, you can do truth tables. But it saves you a lot of time if you do remember DeMorgan's law on this question. All right, and it's not C or D. That is question 23. All right, question 24. A program encounters a division by 0 during execution. What type of error is this? So the program is running right now. So we know it is not a syntax error because a syntax error would be caught at compilation. So now we're left at 3, logic, runtime, and linking. Well, is it a logic error? A logic error, the program would still be able to run, but typically when you encounter division by 0, this typically causes the program to crash. So it is not a logic error, because a logic error, the program can still run, it's just the logic of the program is wrong, something is happening that you don't intend it to do. But here, the program will crash typically if you have a division by 0 and you don't handle it correctly. Is it a runtime error? Yeah, it is. Okay, so a division by 0, it's called in Java, arithmetic exception error divided by 0 error. And linking error, you typically never hear about that in computer science or programming. You don't need to worry about that. That's a distractor answer. Okay, so let's go ahead and summarize. This would be caught at compilation. And this would be parentheses missing or semicolon missing. Logic error. Code still can run. Just error in some logic. This is code runs and crashes. And linking error, it's just a throwing in there, doesn't mean anything. All right, that is question 24. Okay, question 25. A computer science teacher assigns a project where student teams must design a database schema. Each team member proposes a different approach, and a team must evaluate trade-offs before selecting a final design. Which instructional strategy does this activity best exemplify? Well, this has nothing to do with computer science necessarily. This is just knowing your teaching terms. Is this direct instruction with guided practice? Is the teacher just lecturing up front? Is it direct instruction? No, right? It seems like student teams are working together for a project. There is no direct lecturing instruction from a teacher. Is it collaborative problem solving with multiple perspectives? Well, collaborative are students working together to solve a problem. Yeah, it seems like it, right? Oh, sorry. So collaborative problem solving, it seems like students are working together to solve a problem. And does it have multiple perspectives? Well, if you see here, different approaches. So it seems like B is the best answer right now. Is it independent drill and practice? Are students working by themselves, just drilling, practicing word problems or worksheets? That doesn't seem like what this problem is describing. And is it lecture-based, concept introduction? Again, there's nowhere in this problem that suggests it is lecture-based and it's an introduction of a concept. So B is the correct answer here. All right, question number 26. Consider the following pseudocode segment for selection sort. Okay. Assume the array data initially contains 8351. And then we have the code for what I'm assuming is selection sort. What is the state of the array after the first complete pass of the outer loop when I equals 0 finishes? Well, first off, we have the code for the selection sort. So if you don't remember how selection sort works, you can trace through the code line by line and solve this problem. Because luckily, it won't take too much time because it's just asking for the first complete pass. For a second or third or fourth, I would say make sure you remember how a selection sort works. So how does it work? Well, the way I like to describe it is selection sort selects the smallest value in the unsorted portion and swaps. That's my one-liner that I use to help me remember what a selection sort does. So what does that mean? Well, we have 8351. Initially, at the beginning, this whole array is unsorted. Right, so unsorted, sorted. So what selection sort does is it finds the smallest value in the unsorted portion, which would be here, and it go ahead and swaps it to the next portion. So the next portion would be here. You perform a swap. You get 1 and 8. And now, let me erase this part. And now this portion is unsorted. And that is how selection sort works. So what is the state of the array after this first complete pass of the outer loop when I equals 0 finishes? It is 1358, which is right here. But let's go ahead and assume, let's just say you don't remember how exactly a selection sort works. That's fine, right? We know our test taking strategies. Let's go ahead and put that into practice for this question. So we don't remember what selection sort does. We don't know how it works. Let's go ahead and look at the code for a selection sort. It really helps if you can think a little bit broader picture and instead of just thinking about line by line. Here's what I mean. This outer loop right here, it sets I to 0, right? And basically it goes almost all the way to the end. And there's that condition right there. But we don't care because we're only concerned with this first complete pass. So what I'm really concerned about is I0. And then it sets this min index is also I, which is 0. Now, what is this inner loop doing right here? Well, let's take a look. So it first sets j to I plus 1, which is 1. And then it goes through the entire length of the array. And it's checking, is this value right here less than that value right there? If it is, then it sets min index to a new value. So to sum up what this for loop and the if condition are doing, you're basically trying to find the minimum index or the index that contains the smallest value, right? And that's what this if is doing right there. You're comparing all the smallest values, all the values you see, data j, with the current smallest value, which is data min index. And if you find a new smaller value, you update min index to where that new smaller value is. So this inner for loop is find smallest find oh let me change that, find index where smallest value is. So after this inner for loop runs, I have found where the smallest value is, and min at index right there is going to contain index of smallest value. Okay, so let's go ahead and do the next line of code, which is right here, 2 and 3. Draw my array. Let's draw it a little bit better. 8, 3, 5, 1. So after my inner for loop runs, what should min index hold? Well, ask yourself, what is the index of the smallest value? One is the smallest value, right? So the index should be 3. So this should store 3 by the end. So now if we look at the red number 1, that should put inside temp the data I is 1 up here, or I is 0 up here, right? So that should put it 8. Data I is getting data min index. Okay, so what is this data min index? That is data 3, which is value of 1. So I'm going to go ahead and put inside data 0 data 3, which is the 1. So I just ran line number 2 down there. And now I run line number 3. I'm going to put the value inside temp, which is that 8. I'm going to put it inside data min index, which is 3. So I'm going to put 8 right here. So that is question 26. If you don't know how exactly selection sort works, but you're able to kind of think through the different parts of the for loop, then you're still able to solve this problem within reasonable time. But definitely by the time you enter this exam, you have to be super comfortable with for loops, any type of loop, any type of conditional, and be able to think through these types of problems. All right, that was question 26. All right, question 27. Which of the following best describes the difference between a low-level programming language and a high-level programming language? So it helps to think of examples of high-level programming languages like Java, Python, JavaScript, and low-level programming languages like assembly, machine code. And just by having those examples, we can think through these answers. A, are low-level languages easier for humans to read, and high-level languages are closer to machine code? No, that's false. Java and Python, which are high-level, are easier for humans to read, while assembly and machine code, which are low-level, those are closer to machine code. So A is the opposite. A is false. B, are low-level languages like assembly, machine code, closer to machine code and hardware, and high-level languages use more human-readable syntax? Yeah, that's true. You'll see that A and B are kind of the inverse of each other. Oh. So B is the one that's true. C, low-level languages cannot perform mathematical calculations, while high-level languages can. Actually, both can. Oftentimes, high-level languages get compiled down or get interpreted down to a low-level language to perform those mathematical calculations. So C is definitely false. And D, low-level languages are always interpreted. High-level languages are always compiled. You can think of high-level languages that are not compiled, right? Python, JavaScript. So D is false as well. So for questions like this, it really helps if you define low-level, define high-level language, and can come up with examples of each. That'll help you answer these types of problems. All right, question 28. Consider the following pseudocode segment. So we have some for loops, nested for loops, a for loop inside a for loop, and it's asking us what is the output. So let's go ahead and draw my table. I have R, and I might have my condition just to make sure I'm checking it. So for R is 1 less than or equal to 3. That's true. And now I have my string line, and it's currently a blank string. I go into the inner for loop, and it says C is 1. So C has the value of 1, and I have a condition of is C less than or equal to R. So is 1 less than or equal to 1? That is true. So then I go ahead and do line is line plus star. So this is now going to be a star right here. And let me go ahead and put line numbers to help us talk about it. So I just finished line 4. I now go to line 5. And then because I haven't evaluated to false yet, I go to line 3. Okay, so this is one for loop. I go to line 3 and I do C is now C plus 1. So C is now 2. And then I ask, is C less than or equal to R? 2 is not less than or equal to 1. So that is false. So I go to line 5. Because the condition is false, I exit my for loop. And now I go to line 6. And I print line. So what is printed out, I'll just put my output here, is this line right there. I reach line, so because I exited a for loop, I now erase this. I printed out line, I go to line 7, and now I loop back up, and R is now R plus 1, which is 2. Is 2 less than or equal to 3? That is true. And now line is going to be a blank string. Okay, I go to line 3, so C is now 1. And then I ask, is C less than or equal to R? Is 1 less than or equal to 2? That is true. I go to line 5. Line is line plus star. So line is going to be this star. I go to line 5. I loop back up to line 3, the increment. C is now C plus 1, so C is now 2. Let me go ahead and cross it out. C is now 2. I go to condition check. Is 2 less than or equal to 2? That is true. So because the condition is true on line 3, I go to line 4 inside the inner for loop. And I do line as line plus star. So line is now what it was before, but adding another star. I go to line 5. I loop back up to line 3. I go to increment C. C is now 3. And I ask, is 3 less than or equal to 2? That is false. So I go to line 5 and I exit the inner for loop. I go to line 6 and I print line. So out prints that. And then I go to line 7, which is the end of the outer for loop. And now I go all the way back up to R is R plus 1. So R is 3. And then I ask, is 3 less than or equal to 3? That is true. So I now have line is now a blank string right here. From line 2, I go to line 3. C is 1. And I ask, is C less than or equal to R? Is 1 less than or equal to 3? That is true. So line is now line plus a blank, or line plus a star. I go to line 5, which is the end of the for loop. I loop back up to line 3, the increment. C is now 2. I go to the condition check. Is 2 less than or equal to 3? That is true. Because the condition is true, I go inside the inner for loop, which is line 4, and I add another star to line. Okay. I go to line 5, which is the end of the inner for loop. I loop back up to line 3, the increment. C is now 3. Is 3, I go to the condition check. Is 3 less than or equal to 3? That is true. Because the condition is true, I go inside the inner for loop onto line 4, and I add a star to line. I go to line 5, the end of the inner for loop. I loop back up to line 3. C is now 4. I go to the condition check. Is 4 less than or equal to 3? That is false. So I go ahead and go to line 5, the end of the inner for loop, and I exit the for loop. And then I go ahead and print line, which is going to be 3 stars this time. I go to line 7. I'm at the end of the outer for loop. I go to line 1, loop back up. R is now 4. I go to condition check. Is 4 less than or equal to 3? That is false. So I go to line 7, the end of the outer for loop, and I exit that loop, and I'm done. So what is printed? Well, it is going to be B. That is what is printed. All right, that is nested for loops. Make sure you're very comfortable with those loops. That's question 28. All right, question 29. A UML class diagram shows a solid line with a hollow arrowhead pointing from class dog to class animal. What relationship does this represent? So UML class diagram, we have two classes, a dog and an animal. What is that relationship? Now, suppose you didn't know what this was. Solid line, hollow arrowhead. We can still answer this question by understanding the relationship between a dog class and an animal class. Okay, so does the dog contain an instance of animal? Does the dog inherit from animal? Does the dog use a method from animal? Or are dog and animal unrelated classes? Well, first off, this right here, the solid line, this means there is some relationship between these two classes. So you can immediately eliminate D. There's some relationship between dog and animal, but what exactly is it? Does the dog contain an instance of animal? Is that composition? Not quite. That doesn't really make sense for a dog class to contain an instance of the animal class within the dog class construct. B. Does the dog inherit from animal? You can ask yourself this question for inheritance. Are all dogs animals? Basically, is a dog an animal? Or a dog is an animal, if you like periods instead of questions. So that is the test for inheritance. This is an type of test. Yeah, dog inherits from animal. All dogs are animals. A dog is an animal. It passes the is a test. So A is looking good. C, does the dog class use a method from animal class? Possibly, but that wouldn't necessarily be what the line is representing. Really, for this question, you're looking at A and B. Is it composition or inheritance? For an inheritance, you ask the is a test. For composition, show it here. This is the has a test. So, does a dog have an animal? Or if you like periods, a dog has an animal. That doesn't really make sense, right? A dog doesn't have an animal, but a dog is an animal. So here we can see that the one that best represents that relationship is inheritance, or B. An example of composition, or the has a, would be a vehicle has a steering wheel, right? The steering wheel could be a class. The the vehicle can be a class. And so we see that the car has a steering wheel. So make sure you're very familiar with inheritance versus composition, and you should do fine on these types of questions for the exam. That was question 29. Inheritance is a, or composition has a. All right, question 30. Consider the following pseudocode segment. And what is the output? So we have lines of code. And let's go ahead and take a look. We have an array 4, 9, 2, 7, 5. And then we put into result what is at index 0. So if you, it helps you remember your indexes. Let's write them down. And we put into result what's at index 0, which is 4. And then we go ahead and loop through the array, starting at I is 1, going to the end, looking at each value. And what you're asking yourself is this value I'm currently looking at greater than what is currently stored in result? And if the value I'm looking at is greater than the value that is currently stored in result, I want to put that greater value inside result. So by the end of this for loop, what should happen is result should store the largest value in the array. So, and then at line 8, we want to print whatever's in result, which once again should be the largest value that is in the array. So, looking through this array with my eyes, I see that the largest value should be this value of 9 right there. Right? So that should be answer choice D. Now notice I didn't go step by step through this for loop because I really wanted you to see, once you can interpret or read a for loop like this, once you become a little bit more comfortable, it really speeds up these types of problems. So make sure you can practice your for loop comprehension and practice understanding what parts of the for loop are doing, and that'll give you success. Now it's question 30. All right, question 31. In a game that uses a two-dimensional coordinate system, two circular objects have centers at 3, 4, and 7, 1 with radii 2 and 3 respectively. The distance between the centers is 5, and we're asked, has a collision occurred? Meaning, do the objects overlap or touch? Well, let's go ahead and look at the question and grab that essential data first. We're going to be looking at to see if two circular objects overlap or touch. Okay, and we have a couple of pieces of information. We have a circle at 3, 4 with a radius of 2, and we have a circle at 7, 1 with a radius of 3. And we're told the distance between the centers is 5. Okay, and that is really key. The problem gives us a massive shortcut because if we didn't know that distance is exactly 5, we'd have to calculate it using the distance formula between those two center points that we were given. But because we were given that information, the distance is 5, we don't need to remember the distance formula and we can skip calculating that distance. Just a quick refresher, if you were to encounter this on the exam and you weren't given the distance formula, the distance is given as d equals the square root of x2 minus x1 squared plus y2 minus y2 minus y1 squared. Okay, that's just in case you need to know that for the actual exam. All right, let's go ahead and graphically represent this. That might help us get a better idea of what exactly is going on in this question. So I have 2, 3, 4, 5, 6, 7, 8, 9, and 7. 1, 2, 3, 4, 5, 6. So I have 2 points, one at 3, 4 as circle 1 with a center at 3, 4. And we have 7, 1, 4, 5, 6, 7, 1. Okay. So here are our two centers, and we don't need to draw this perfectly to scale. I know I was pretty good about keeping my x-axis, the ticks, pretty good, and a y-ticks pretty good, but this is just a conceptual sketch to guide our logic. one other thing we know is the total distance bridging the two is 5. So D is 5. Okay. And now I'm going to go ahead and draw those line segments. So we know the radius 1. Let me go ahead and do that C2. So we know radius 1. R1 is 2. And I know R2 is 3. And I drew them as arrows or rays, to be more precise, to kind of reflect that this is a radius, and it can go all the way around the circle. But if you want to get rid of those arrowheads, that is a-okay. Gonna erase that. Say this terminates here, and that terminates, I don't know, somewhere here. I'm not too certain. Again, this is not drawn to scale. Okay. So our first circle, circle 1, reaches out towards the middle of these two, the intersection of the two circles with a radius of 2. And our second circle reaches back with a radius of 3. Visually, doing this freehand on the screen, it's kind of hard to tell if these lines cross, touch, or miss entirely. But we don't really need a ruler because we can just trust the math. All right, so we're told that this distance is 5, and we're told that the radius is 2 and 3 respectively, and you should notice something. 2 plus 3 equals 5, right? Which is R1 plus R2 equals the distance. So to test for a collision, we just simply compare that total distance to the combined reach of the radii, and we add them up. So if we take the radius of the first circle, which is 2, and the radius of the second circle, which is 3, and add them up, we get exactly 5. And because the combined reach of the radii is perfectly equal to the total distance, that means we know that these two circles touch at exactly 1 point, and I'll indicate that here with that small line. Because the combined reach of the radii is exactly equal to the total distance between the circles. The math guarantees that the outer edges of the circles meet at exactly 1 point. So they are touching. So looking back at the question, it asks, has a collision occurred? Which is defined as they're overlapping or touching. And because they touch, our answer is yes. Okay, because they're touching. You can also reason about it this way. A circle is perfectly circular. It's round all the way around. So if I was to draw the circle, again, this is not drawn to scale. I have to draw circle 2. It's okay if my circle is not perfectly drawn to scale, as long as I have a geometric sketch to kind of visualize and see that the distance would be exactly equal to the 2 furthest reaches of the radii. All right, I hope that helped you understand question 31 a little bit better. Again, it's okay if you don't memorize these formulas, such. All right, I hope that helped you understand question 31 a little bit better. Again, if they don't give you the distance, you might need to understand how to calculate that distance on the exam. but they should be giving you that formula if you do need to know it. And just make sure you know how to do a quick sketch to verify these types of collisions. That's question 31. Question 32. Which of the following programming style conventions most improves the readability of code? So if we use single character variable names, does that improve the readability of code? Right, that's what we're looking for. Well, no, if we use single character variable names, although that does minimize typing, that makes it harder to read the code both as the initial programmer and for any programmers coming after you who has to maintain your code. You want to make sure you use descriptive variable names. So it is not A. Writing all code on as few lines as possible to reduce file size. So yeah, on as few lines as possible does negligibly possibly reduce file size of code. We really want those indentations to help understand what is inside the for loop, what's inside the if condition. So this actually harms the readability of code, B. Do we want to use descriptive identifiers, consistent indentation, and comments? Yes, that would definitely improve the readability of code. If we use descriptive identifiers such as good variable names, good function names, consistent indentation to show what belongs inside what, loops and conditionals, as well as comment to help ourselves remember what we did a week ago, or people maintaining our code a year from now. That would really help. And D, avoid use of functions to keep all logic in one place. That actually also harms the readability of code. If we have a bunch of code inside one function, well, what if that parts of that functionality we want to repeat elsewhere, and then it's just a giant code block? That really harms the readability of code. So the answer choice is C. That is question 32. Question 33. What is the worst case time complexity for searching for a value in an unsorted array of n elements using linear search? So a couple of things stick out. We're looking at worst case, which is BigO of something. And we're looking at an unsorted array of n elements using linear search. So linear search, if you forgot, let's go ahead and just draw an array of values. It's unsorted. Linear search means you start either at the beginning of the array or at the end of through element by element by element. So you look here and then there, and so forth. So if you have 6 elements in your array, you have to look at 6 things. If you have 100 elements in your array, you have to look at 100 things, right? And now we make that a variable. You have n elements in your array, which is what this is saying right here. Then you would have to look at n things. So that is a big O of n. And that's how you can easily answer these types of big O questions. All right, that was question 33. All right, question 34. A file with the extension .csv is best described as which of the following? Now, this question, it really requires you to know what CSV stands for. Okay, and CSV stands for comma separated values. And just based off that definition of CSV, comma separated values, or really acronym, you can see that B is the answer. A plain text file where data values are separated by commas, or comma separated values. This question really requires you to know that definition, CSV, and it's really hard for you to logic your way through each of these. But you might be able to come up with examples on the exam that might be able to help you eliminate some of the other ones. For example, looking at answer choice A, a compressed archive containing multiple files, you might think of the zip extension or the tar extension. And that's not .csv. So that might cause you or help you eliminate A. What about C, an encrypted file that requires a password to open? Have you ever encountered that? Maybe, but you can encrypt a lot of things that require a special password to open. This isn't unique to any really particular type of file. You can password encrypt a lot of different things. So it's pretty broad. D, a database file that can only be opened with specialized software. Again, that kind of makes me think of databases and maybe putting a password or something on it. But yeah, once again, this really requires you to know what .csv stands for. And so make sure you have that in your vocabulary list, comma, separated values. The only one you might be able to eliminate without knowing CSV is answer choice A. All right, hope that helped. That is question 34. All right, question 35. Consider the following class definitions. So we have two classes here, class vehicle and how it's defined. And then we have class truck, which we're told extends the vehicle class. So what do we mean by extends? Well, another way to explain that is it inherits from. So if we were to draw a UML class diagram, or a simplified version, we might have the vehicle class, and extending from it or inheriting from it, we have the truck class. Okay. And then we also have a couple of other things. We have private, and some public methods right here. Okay. And typically we use minus signs to denote private and plus signs to denote public. And we're looking at the following question. Which of the following statements about these classes is true? Let's look at them. A, can the truck class directly access the make variable without using get make? So here we see the truck class. And does the truck class have a make variable? No, it doesn't, right? The make variable, if we look up here, it belongs to the vehicle class, right? It's inside the vehicle class. And we notice another thing is that it is private. So something to know about private is that other classes cannot directly access private things. And yes, I know that the truck class does extend the vehicle class, but if you can see in the UML diagram, they are still different classes. So because the make variable is in the class vehicle and it is private, the truck class cannot directly access that make vehicle. So A is false. Let's look at B. B, the truck inherits the get make and set make methods from vehicle. So we see in the vehicle class that we have a get make and we have a set make method. And what B is saying is the truck class inherits those two methods from vehicle. And is that true? And it is true because the get make and the set make methods are public, meaning the truck class inherits those two methods from the vehicle class, and they can use those two methods. So B is good, but maybe C or D could be better. So C, the vehicle can call get tow capacity because truck extends it. So if we look here, we have the vehicle class up top. There is no get tow capacity, but the truck class does have a get tow capacity right here, right? So C is saying, well, that vehicle class, that parent class, can call get tow capacity from the truck class because that truck class extends the vehicle class. But that's not really how parent-child relationships work. And you'll hear me use that analogy, the parent-child, because I think that kind of perfectly illustrates how class inheritance works. The child class inherits everything public from the parent class. But as we know in real life, parents also keep things private and secret from their kids, right? But the relationship doesn't flow the other way. The parent class does not automatically get to take from the child. So answer choice C is wrong because the parent, the vehicle class, does not automatically get stuff from their child class just because it's public in the child class. So the C is wrong. And D, truck and vehicle have no relationship to each other. Well, we drew the UML diagram and we also see this keyword extends. So obviously truck and vehicle do have a relationship to each other. So D is wrong. So that means B is the best and the only true answer. Once again, to rehash, I like to think of inheritance in terms of real life or make-believe real life inheritance with a parent and a child. If something is denoted as private, well, that means no other class can look at it, access it, inherit it. So in the vehicle class, in the parent class, we have some private things. And just like in real life, sometimes parents keep things private or secret from their children. So the children do not have access or privy to the information of that from the parent class if it's private. But if the parent class makes things public, like the get make, the set make, then they're basically telling their child class, yeah, you can inherit that. This is for you. That's the analogy I use to kind of make this inheritance make sense for me. I encourage you to create your own analogy, your own story that makes sense for you. All right, that is question 35. All right, question 36. Which of the following is a characteristic of the procedural programming paradigm, but not the object-oriented paradigm? And we have A, B, C, D, but basically we're trying to compare and contrast procedural programming paradigm and object-oriented paradigm. And just by looking at these words, we know that object-oriented paradigm probably is object-oriented or focused on or around objects. And because of that naming scheme, we might be able to reason out that the procedural programming paradigm, if object-oriented paradigm is focused around objects, maybe procedural programming paradigm is focused around ... procedures. Again, that's if you don't know what each term actually is. Definitely add it to your vocab bank, write the definition down, but that's a good assumption. So looking at A, B, C, and D, which one makes the most sense? Well, B. Now let's look at A, C, and D, and let's explain why those three collectively would probably be wrong. Imagine programming without the use of loops and conditionals. How could you write a program like that if you can never have options, which is what conditional gives you, or the ability to repeat code a set number of times, which is what loops allows you to do? That would probably be a very bad programming language, a very bad paradigm, and it probably wouldn't exist except for like a pet project or something. Same thing with C and D. Imagine not being able to use variables or data types, or no ability to reuse code, which is what D has. So just by thinking this through, A, C, and D, imagining a programming language without any of these three, that would probably be a pretty fast, dead programming language. All right, that was question 36. Question 37. Consider the following pseudocode segment involving a string. So we have some code. I'm going to go ahead and just number them right off the bat. And we're asked, what is the output? And we're given a quick note that there's this method substring ij. It returns the characters in a string starting at index I and ending at index j exclusive. Great. So if you don't know what substring does, which is this method right here, they tell you what it does. Well, let's go ahead and step through this line by line and make sure we understand how a for loop works. So we have the string word, or it's a variable, and it contains a memory address, a reference to the string word, or the string computer. And I'm just going to go ahead and write the indices right now, because I know I'll need it later. And I have this string result, which is blank so far. And now I have a for loop. Awesome. So I'm going to draw my table. Let's go here. So I have my table I, and it says I is initially word.length minus 1. So what is the length of word? Well, it is 8. Okay, so I is initially 8. Now, careful, if you said 7, the last index is 7. But when we count how many letters are in a string, we start with the number 1. But we start counting indices at 0. But we start counting at 1. So C is 1, O is 2, M is 3, 4, P, U, T, E, R. So there are 8 letters there. Okay, and then we go to the next part. We check the condition. Is I greater or equal to 0? That is true. And because that is true, we go to line 4 and we do result is result plus word.substring I plus 1. So I'm just going to do result here. I'll erase this one right here. Oh, that's a little too much. So result was this blank string. And we're going to go ahead and add word.substring I plus 1. So we're told that the substring ij method returns the characters in a string starting at index I, ending at index j. So what is this? I'm just going to write it out for the first one. What is I? It'd be 8. And what is I plus 1? It'd be 9. Oh no, I made a mistake. Did any of you catch that? Well, I actually isn't 8. If I look up above on line 3, it says int I is word.length minus 1. So the length of the word is 8. I need to subtract 1, so it is now 7. Oops, silly me. Even teachers make mistakes. All right, going back to line 4 now, it's going to start at I and go to I plus 1, which is 7, 8. And the note says that it's going to return the characters in a string starting at index I, just starting at index 7, and ending at index j, but exclusive, meaning not including. So this means not including. So that is the same thing as this plus R, which is R. The result is R right now. Okay, we go to line 5, and then we loop back up, and we go to the change, which is a decrement this time, and it says I is I minus 1, so I is now 6. We then go to the condition, which is I greater or equal to 0? It is. As the condition is true, we go to line 4 inside the for loop, And we now do the right side, which is result plus word.substring I plus 1. So result is R right now, plus word.substring I plus 1, which is 7, which is R. And what is at index 6 going to 7, but not including 7? Well, that'd be this E, right? Oops. So we get that. Oh. So we get RE. Okay. I'm done with line 4 now. I go to line 5. I loop back up. I go to the change, which is I minus 1. So I is now 5. I go to the condition. I check is I greater or equal to 0. That's true. So now I go to line 4 because the condition is true, which is inside the for loop. And do result is result, which is RE plus word.substring 5 index I and I plus 1. So that is RE plus T, which is RET. Okay. I go to line 5. I loop back up, which is the decrement, and I is I minus 1. I is now 4. Gives us more room. I go to the condition. I check is 4 greater than 0. That is true. As the condition is true, I go inside the for loop on line 4, and I do result, which is RET plus word.substring I plus 1, which is RET plus what is at index 4? It is U, which is okay. And I'm going to go ahead and speed things up a little bit. I think you kind of get the gist of it. So I go to line 5. I loop back up. I decrement. I is now 3. I go check my condition. It's 3 greater than 0. That's true. And because the condition is true, I go inside the for loop, which is line 4, and I do result plus word.substring I plus 1. So that would be RETU plus word.substring 3, 4. I'm just going to shorten it, which is RETUP. Okay. I go to line 5. I loop back up. I go to the decrement. I is I minus 1. I is now 2. I go check my condition. Is 2 greater than 0? That is true. Because the condition is true, I go inside the for loop on line 4, and I do result, which is RETUP plus word.substring I and I plus 1. What is at index 2? It is M. Okay. I go to line 5. I loop back up. I is now I minus 1. So I is now 1. And I can't see that. Okay. I go check my condition. Is 1 greater than 0? That is true. So I go inside a for loop. Result is result plus word.substring I plus 1. So RETUPM plus word.substring I plus 1, which is RETUPM. Next one is O. Okay. Line 5, I loop back up, go to the change, the decrement, which is I is I minus 1. I is now 0. I check my condition, which is I greater or equal to 0? That is true. Because the condition is true, I go inside a for loop onto line 4. Result is now result plus word.substring I plus 1. So result plus word.substring I plus 1, which is RETUPMOC. Index 0 is 1. Okay. I reach line 5. I loop back up, which is going to the decrement, the change. I is I minus 1. I is now -1. I check my condition. Is I greater or equal to 0? Well, I is -1, so that is not greater or equal to 0. So because that's not, I exit my for loop, go to line 5, go to next line, and I print result. And this is what is printed out. And it looks like that's answer choice B. All right, that was question number 37. Worked out. I hope that helped you understand how for loop works, as well as how you can use methods that you might not be as familiar with, but they should give you these notes on the exam to help you out with these types of methods. But make sure you check the TExES 241 exam packet. They tell you what is given to you on exam and what you have to go in knowing. So if this method substring isn't given to you on that packet, make sure you might just study it and brush up on it. All right, that is question 37. Question 38. A software team divides responsibilities so that one group writes the user interface, another writes the database layer, and a third writes the business logic. Before integration, each group tests its own module independently. This practice is best described as, so some key things I'm noticing. Before integration, they test each module independently. Okay, and we're dividing responsibilities. So just looking at these answer choices, which one seems to be like what they're doing? Well, if you don't know, let's go ahead and add each of these terms into your vocabulary list and find the definitions for each one so that before you go into the exam, you know what each type of testing is. But let's go ahead and look at the first one. Acceptance testing. What is that? Well, think of it. Acceptance testing. Basically, one way you can think of it is, do the end users, whoever's going to use this program, this software, whatever it is, do they accept the changes you're making to it? Basically, you're trying to verify that this software, this product, meets the business needs and is ready for production so that the people who are going to be using it will use it. That's not quite what the scenario is describing though, right? It's describing each group testing its own module independently. It's not really saying, hey, we want to make sure the end users will accept our software, they will accept the changes. So it's not acceptance testing. What about B, regression testing? Well, if you think about the word regression, so we have some software, we're now updating it, we're making some changes, we're patching it. Basically, regression testing is making sure your new changes, your new updates don't break anything in the past history. You're testing towards regression, past history. Another way to say it is you're trying to make sure your new code changes or bug fixes don't break already existing features in your software. Again, that's not what is being described. It's describing each group testing its own module independently. This is what we're focused on right here. So it's not B. Is it unit testing in a modular development approach? Well, what does unit test? What does modular mean? Well, if we look at the word modular, it kind of looks like module, right? Basically, you can think of it as individual building blocks of code that each can work independently that you put together to make a larger piece of software. You can think of it like a brick when you're building a house. Each brick serves its function and can work independently. And then you put another brick and you test each brick first. And then you want to make sure each brick works independently first. Just like you want to make sure each function are, for example, in this case, the user interface, the database layer, the business logic. They all work independently first before you try to combine them all together. And that's what this scenario is describing. Okay, so it's answer choice C. And black box testing, let's go over that one. Basically, you think of the software, the code, as a black box. You can't see inside it. You don't necessarily know what's going on inside of it, but you can put stuff into the black box and you can see what comes out of the black box. And you kind of want to see basically, is your software kind of working? This is a very, this is a very broad way to look at testing. It's not, once again, specifically looking at this, each group testing its own module independently. So it's not D either. So that's why C is the best answer for question 38. All right, that was 38. Question 39. Consider the following recursive function. So we have some function right here, and we are asked what is the value of mystery 5. I'm just going to go ahead and number these lines of code. Now, the thing about a recursive function is that it is a function that calls itself. If you don't know that, that's a-okay. There's a couple of things to keep in mind with these recursive functions, and we'll be sure to go over them as we trace through this code. So we go ahead and call mystery 5. I'm just going to go ahead and write that down. So I'm calling the function mystery with the parameter of 5. So I go ahead and go to line 1. And this value of n in here, n is equal to 5, right? Because we pass in the argument, the value of 5, and n is now that value of 5. And one thing you need to know, nothing new, code runs top to bottom. Okay? So we go to line 2 now, and we check, is n, which is 5, less than or equal to 1? That's false, right? So we don't go inside the if condition, we don't go to line 3. We go to the end of the if block, which is line 4. We go to line 5, which is return n times mystery n minus 1. All right, I want to return. It's telling me to return, but I first need to calculate this mystery times this value of mystery n minus 1. What is that? I don't know it yet, right? So I'm going to go ahead and put a bookmark on here. And I'm just going to notate to myself that when I call mystery with a value of 5, this is equivalent to n times mystery n minus 1. And let's just go ahead and put those values in it. So n is currently 5, so I'm just going to put 5 there. And n minus 1 is 4, so I'm going to put a 4 there. Okay. Now we see the recursive part, right? We're calling the function mystery while we're currently inside the function mystery. So a recursive function is a function that calls itself. So what do we do when we get a call to the function mystery? Well, we go ahead and go to line 1, right? We go to the function, call a function, go to the function. Okay? Again, we're just doing what the code tells us to do. We're calling mystery 4, so we go to mystery with the value of 4. And n should be 4 right now. Sorry, it should be 4. All right, so we're line 1 now in the mystery 4 call. And now we go to line 2. Is 4 less than or equal to 1? False. The if condition is false, so we skip the if, go to the end of it, and then we go to line 5. And it says return n times mystery n minus 1. Once again, I don't know what mystery n minus 1 is, So I'm going to put a bookmark on this mystery call. And this is equivalent to n, which is 4 right now, times mystery n minus 1, which is 3. Okay. So again, when we call a function, we want to go to the function. That's rule number 2. So we go to line 1. N is currently 3. And then we go to line 2. Is 3 less than or equal to 1? That is false. So we skip the if portion and we go to line 5 and we return n times mystery n minus 1. Well, what is mystery n minus 1? We don't know that yet. So I'm going to put a bookmark here and I'm going to say this is equivalent to returning n, which is 3, times mystery n minus 1, which is 2. And I'm just going to go ahead and move this over to the side a little bit. Okay. All right. So I am calling a function. When you call a function, you go to the function. So now I'm on line 1, and my parameter n has a value of 2. I go to line 2. I check the condition. Is 2 less than or equal to 1? That is false. So because the condition is false, I skip the if portion, go to line 5, and I return n times mystery n minus 1. Once again, I don't know what mystery n minus 1 is, so I'm going to put a bookmark there, and that is equivalent to returning n, which is 2, times mystery n minus 1, which is 1. Okay, so I go to the function, line 1, n is now 1. Let me make that note. And we go to line 2, the next line of code, and we ask, is n, which is 1, less than or equal to 1? And that's true, right? So because that's true, I go inside the if condition, and it tells me on line 3 to return 1. Now, what does it mean to return 1? Well, you return to whatever called you. So that's number 3. Return to what called you. Okay. So line 2, or rule number 2, when you call a function, you go to the function. Rule number 3, when you're returning, you return to what called you. So right here, what called this function mystery n minus 1? Well, I'm going to return a value of 1 to that call. So this is going to be, let's go ahead and draw in red. This is now 1. When I call the function mystery with a value of 1, it tells me to return 1. So it's like a variable in that kind of sense. You replace it with the value it returns. And it returns to line 5, right? That is when we called return n times mystery n minus 1, which if you look down here, that was 2 times mystery 1. We now know mystery 1 is a value of 1. So I can replace that mystery 1 with a value of 1. And now I do 2 times 1. What is 2 times 1? Well, that's 2, right? And if we look at line 5, it tells me to return that value. Well, where do you return to? Let's look at rule number 3 again. Return to what called you. So what called that? It was this mystery 2 call, right? So mystery 2 is equivalent to 2 times 1, which is 2. And we see that I need to now do 3 times 2, which is 6. So I have a value of 6, and I'm on line 5 again. I return 3 times 2, which is 6. And where do you return to? You return to what called you, which is the function call mystery 3. Okay, that's 6. And you return to line 5 once again. So we're now at line 5 once again, and it says return n, which is 4, times mystery 3, and we computed that mystery 3 is 6. So now we do return 4 times 6, that is 24. And you return to what called you, which is that mystery 4 call. Now we get 24. Now we're once again inside the mystery 5 call on line 5, and it says return 5 times mystery 4. We calculated mystery 4 is 24. So we do 5 times 24, which is 120. And we go ahead and compute 5 times 24, 120. And we're going to return that to what called it. So mystery 5, that is now 120. And it asks, what is the value of mystery 5? Well, we just computed that. It is 120. Okay, so that is question 39. A couple things to remember about recursion are for any function tracing. Code runs top to bottom. Another corollary I often add is maybe rule 0. Code is not magic. Okay, code is not magic. Code runs from top to bottom. When you call a function, you go to that function. And when you return from a function, you return to what called you. Knowing these 4 things will really help you trace any function call. All right, that is question 39. All right, question 40. Consider the following propositions. P, it is raining. Q, I carry an umbrella. Which of the following represents the statement? If it is raining, then I carry an umbrella. And then we have some notations, that, right? So let's go ahead and take a look at these, starting from A. Now, this notation, that is the equivalent of an and. Okay. And you do need to memorize this. And the best way I know how to memorize this is that the caret that goes up, notice how that matches the n, right? So caret and the n also has like a hump. So that's how I know, or that's how I remember that that is an and. So if we were to write P and Q, it would look like this. It is raining and I carry an umbrella. That is and. So I got B. B has this symbol right there. That is an or. Okay, so the way I remember what is an and or an or is that middle hump. If it has a hump, then I think, oh, and also has a hump. So the other one must be an or. So that is saying it is raining or I carry an umbrella. P or Q. Now, this other one, P leading the arrow pointing to Q, that is the same thing as if it is raining. If P is true, then I carry an umbrella. So you can think of it as if P, then Q. If P is true, then Q is true. And that seems to match best what this question 40 is saying. Let's look at D though. D is saying if Q, right? If Q. So if I carry an umbrella, then it is raining. So that is the same thing as if Q, then P. But we are concerned with this statement, if it is raining, then I carry an umbrella, and that would be answer choice C. Propositional logic, it's part of discrete math, but hopefully that helps you remember the difference between an and or, and how to kind of look at these questions. All right, that's question 40. Okay, question 41. A program is supposed to print the even numbers from 2 to 10. The programmer writes the following code and gives you the code. But the output is 2468. But the expected output, what they want, should be 246810. Which of the following fixes the error? And it really helps if you're very familiar with the for loop. Once again, you can, if you want to, trace through line by line. But by this point in time, I'm going to assume you've seen enough of my videos for prior questions about for loops. And I'm going to kind of think more meta about this. So right now, this code prints out 2468. And we want to make a change to make it print 246810. Looking at answer choice A, would changing the increment from adding 2 to adding 1 make it print 246810? Probably not, right? It'd probably print 2, 3, 4, 5, 6, dot, dot, dot. It wouldn't print 246810 because it just increment by 1 each time. So it's not answer choice A. Answer choice B, currently the condition is I is less than 10. Would changing that to I is less than equal to 10 be correct? Yeah, it seems about right. Currently it is printing 2, 4, 6, 8. But when I is 10, it then goes to the condition and checks, is 10 less than 10? Which is false. So it exits the for loop and it doesn't print that value. But if we do change it to I is less than or equal to 10, that should print that 10 value. Looks good so far. Look at answer choice C. What if we change that initial condition from I starting at a value of 2 to I starting at a value of 0? Well, then wouldn't it print 0, 2, 4, dot, dot, dot? We don't want it to print 0. So answer choice C is wrong. What if we change it from print I to print I plus 2? Well, currently it's printing I, and it's printing out 2, 4, 6, 8. If we change it to print I plus 2, wouldn't it print 4, 6, 8, dot, dot, dot? But we do want that 2 to print out, so D is incorrect, right? Because we want 2 to print out as well. So B is the answer. And if you do trace this line by line, if you need extra practice of for loops, I encourage you to do so. You'll see that B gets us what we want. All right, that is question 41. Question 42. Consider the following pseudocode using a stack class with methods push, pop, and peek. We have a bunch of code. What is the output? So let's go ahead and number our code. And let's just go through it line by line. Line 1, I create a stack. So here's my stack. And on line 2, I push the value 10. So I'm going to push the value 10, and here's my value of 10. Okay. Line 3, I push the value of 20. Here's my value of 20. Line 4, I push the value of 30. Here's my value of 30. Line 5, I go ahead and pop the value and assign it to variable A. So when you pop something from a stack, notice how can you access the values inside this data structure? You have to go from the top, right? And you can only get what is on top. So you pluck that 30, which is the value on top, and we give that to A. Line 6, we push the value of 40 into the stack. Now on line 7, we're going to peek. Now, I don't know what you think about when you think about peeking, but I think of like kind of looking at the top of the stack and saying, oh, I'm looking at you. I see the value is 40, and we grab that value, right? But we don't actually take the value out. We're just peeking at the value that is at the top. Line 8. Now I'm going to go ahead and pop the value off the top from the stack. So we pop it off, grab that 40, and we pop it off into C. So now we print A, B, C. So it should be 30, 40, 40. All right, that is a stack. And remember, a stack is the last number in is the first number out. And you should know the difference between a peek and a pop. Peek, you're just looking, not taking. Pop, you take. All right, that was question 42. Question 43. How many bytes are required to store an array of 500 characters if each character uses 16 bits? All right, so one thing you do need to know for this, and write it down in your vocabulary, 1 byte is 8 bits. Okay, and that might help you with the math that you have to do for this problem. You'll see the answer choices are all in bytes. So we want to get this bits into bytes. So it's 16 bits converted to bytes is 2 bytes. Okay. So each character uses 2 bytes. So 500 characters is how many bytes? Well, 500 times 2 is 1,000. Okay, that's answer choice B. So make sure you know how many bits are in a byte and can do some of this simple multiplication. That is question 43. Question 44. A school district is considering integrating AI-powered tutoring systems into computer science courses. Which consideration is most important for the teacher when evaluating this technology? Let's get the answers. A. Whether the AI system can fully replace teacher instruction. Well, besides that being a pipe dream and probably not going to happen anytime in the near future, we want to make sure that the AI tutoring systems are integrated, right? And for the teacher, we don't really think, or how should I say this? I don't think an AI system can ever fully replace teacher instruction. There's a lot of things like there's micro events that happen in a classroom that an AI system can never fully replicate, can never fully react to that a teacher can. So A is just a bad answer all around. B, whether the system aligns with curriculum goals, supports diverse learners, and protects student data. These are things we should be concerned about for as a teacher, right? Does the AI tutoring system align with curriculum goals? Is it teaching the correct content? Does it support diverse learners? Is it helping every student succeed? And very important, is it protecting student data? A lot of these AI systems, they take whatever data that you give it and they use it to train the system itself. And that can be a little dubious in how it actually protects student data. So those are important concerns as a teacher. C, whether the system is the newest available product on the market. I don't know about you, but as a teacher, I kind of get a little about the newest fad. They seem to change year over year. So I personally don't necessarily care about the newest available product on the market. And I think B is more important when evaluating this technology. And D, whether the system can grade all assignments without teacher input. Well, that'd be nice, right? It'd be nice if the system could just grade everything. But personally, I think B is more important. Additionally, I also think that it is important for the teacher to manually grade by themselves some of these assignments so that you know what students are struggling. So that's why D is not a good answer and B is the best answer. That's question 44. Question 45. Consider the following pseudocode segment. So we have a class here, shape. We have a class here, circle, extend shape. And just to draw that relationship out, we have a shape class, and extending from it, we have that circle class. Okay, so circle inherits from shape. And now we go ahead and create a variable s, and we say that it's pointing to its shape object. It's going to be a reference variable because it's an object. But when we actually create it in memory, it's going to be some circle object. And now we do s.draw. And the question asks, what is the output? Well, let's go ahead and go through this code. I've already shown line 1 on the right-hand side. When we do line 2, s.draw, you can think of it as going to this variable s, going to the memory address that is stored in s, following it, and then it seeing, oh, it's actually a circle object that is being stored. So when I call this draw method, it's going to go to the circle draw method, okay, which is this one right here. It's going to go to the draw method in the circle class because it's going to use polymorphism and see that when it actually goes to the object, it sees it's actually a circle object. So it's going to call that draw method from that circle object. And it's going to go ahead and print drawing a circle. Okay. So polymorphism, in this case method overriding, is going to cause the circle version of the draw method to execute and run. And that visual that I showed on the right-hand side will help you remember or how to illustrate this type of what's going on in the program. Question 46. In the design of a software system, a developer treats a sorting module as a black box, providing input and checking the output without examining the internal code. Which design concept does this illustrate? Alright, just looking at these definitions or these terms, make sure you write these vocabulary terms in your vocabulary list and write the definitions down as well. I'm just going to read some definitions I found online. Basically, stepwise refinement, it's a top-down design strategy focused on breaking down a system into smaller procedural details rather than concealing implementation. Again, that's not really what this question is describing. You're providing input and checking output without examining the internal code. So A is not the best answer for this. Is it B, information hiding and encapsulation? The definition you can find online is hiding internal data and the implementation logic inside a module or object, allowing interaction only through a defined public interface. So we kind of had the same thing of hiding internal things, right? The black box, we don't check the internal code. Information hiding, we're also hiding something from our view. So B could be correct. C, rapid application development. This term is a software development methodology focused on fast prototyping and iterative delivery rather than structural abstraction. Again, there's nothing about fast prototyping and iterative development in this question 46. So that's not the best. And on D, white box testing, well, white box, black box, don't they kind of seem opposite of each other? But just to give you a definition, the definition I found online is the direct opposite of black box testing, requiring full visibility and examination of the internal code structure and logic. So again, the exact opposite, you can fully see what's going on, but black box, we're hiding things, we can't see what's going on. So of these four answer choices, B, information hiding and encapsulation, is the design concept that this best illustrates. That is question 46. Question 47. A teacher has an unsorted list of 100 student test scores and needs to find the highest score. Which algorithm strategy is most efficient? So here we're looking for an algorithm and looking at efficiency. So when you see that, you should immediately think of BigO. Okay? And let's look at A, B, C, D. A. Should we sort the list first and then return the last element? Well, if we sort the list first from ascending order, lowest to highest, then the last element should be the highest score, right? So that sounds pretty good, but how long does it take to sort a list of the algorithm strategies that we know? Well, the best one might be merge sort, which would be in log n. And then returning the last element would just be BigO1, right? So that is basically the main thing is in log n. Can we do better than that? Let's look at the other answer choices. B, can we use binary search to locate the maximum? Would that be most efficient? Well, binary search is log n. But the key thing is this is an unsorted list. You cannot use binary search on an unsorted list because it relies on eliminating half the search space each comparison. The only way you can safely eliminate half the search space is if the list is already sorted. So that can't be correct. B cannot be correct. C, what about just looking through the list, tracking the maximum value you've seen so far? Well, that's like linear search, right? So you just keep track of the maximum value you've seen so far, linear search, looking at each thing, that's just BigO n. And BigO n is better than this n log n that we have on A. So far, C is the best one. What about comparing every pair of elements and returning the winner? Now, think about that. It might seem like you're doing a linear search, but imagine you have 100 elements. It's not just comparing 1, 2, 1, 3, 1, 4, 1, 5, dot, 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 199, 100. It's also comparing 2, 3, 2, 4, 2, 5, 2, 6, and so forth, right? So that would actually be an outer loop of, the outer loop would run n times for 1, 2, 3, 4, every element. The inner loop would run basically n minus 1 times, getting consecutive smaller. That is basically BigO n squared. So the best possible way to go through an unsorted list from these answer choices is answer choice C. Okay, so make sure you know your BigO, but it's okay if you don't memorize your BigO, as long as you're able to reason it out. That's question 47. Question 48. Which of the following best describes the purpose of an integrated development environment, or IDE? This is one of those questions where you really just need to know the term what IDE is. It's really helpful if you have programmed in the past, because you've definitely used an IDE in the past if you've programmed. But if you haven't, then just add these terms to your vocabulary list and try to memorize these definitions. Again, sometimes the test has these questions where it's like, where did that term come from? But that's just the case with these tests. A tool used exclusively for managing project timelines and team communication. That's just a typical project management tool or collaboration tool, and that is not an integrated development environment. B, a software application that provides a code editor, debugger, and build tools in a single interface. Yes, that is describing an IDE. Think of Visual Studio Code, think of JCreator, Eclipse. These are places where it has all those things combined to make your life as a programmer a lot easier. So it is B. C, a hardware device that connects multiple computers for collaborative coding. Not quite either. This might describe what we call a KVM switch, which keyboard, video, and mouse, that allows you to kind of connect multiple computers. That's not an IDE. D, a testing framework used only for running automated test suites. This would be like a test automation framework like JUnit, PyTest. It's not describing an IDE either. So the answer choice is B. Once again, make sure you have these terms written down: project management tool, IDE, AVM switch, and testing automation framework. All right, that's question 48. Question 49. A committee of 10 teachers must choose a chairperson and a secretary. How many different ways can these two positions be filled? All right, so from 10 people, you're trying to choose 2 to be chairperson and secretary. And we're looking at all the different ways these two positions can be filled. So we're looking for some permutation or combination type of thing. The first thing you need to ask is, does order matter? Right? So does order matter in here? Is the chairperson the same thing as a secretary? No, they're not, right? So because chairperson is not the same thing as a secretary, the order does matter. So yes, order matters. That means you must do a permutation. Okay, so the permutation can be shown like this, which is equivalent to 10p2, which is 10 factorial over 8 factorial. Okay, this is the same thing as, let me write the formula, p the total, the r what you're choosing, okay. Now I don't know about you, I don't want to do 10 factorial, but luckily we can break that down. That is the same thing as 8 factorial times 9 times 10. And with math, we can cancel out like terms, so we get 90. Okay. And there you have it. So for this exam, make sure you do remember those formulas of permutation and combination, and these questions should be relatively easy. That's question 49. Question 50, last one. Consider the following pseudocode segment. So we have a 2D array right here, 2D array, and we have a for loop doing something, and we want to print out something at the very end. And it's asking what is the output. So I'm going to go ahead and write line numbers. Let's go ahead and draw line 1. This might help us out. So we have a 2D array of 5, 10, 15, 20, 25, 30, 35, 40, 45. And we have rows going down. So this is row 0, row 1, row 2. We have columns going that way. Column 0, column 1, column 2. Okay. Might draw some dotted lines. So setting up these problems makes your life a whole lot easier. That's number 1. Number 2, or line 2, you go ahead and create this variable sum, and it's going to have the value of 0 right now. Okay. Line 3, we go ahead and create, we have a for loop, and then we have variable r, and it is assigned the value of 0. And we now go check the condition, is r less than 3? That is true. So then we do sum. Sum is sum plus grid rr. So what is grid rr? Well, grid rr would be grid at row 0 and column 0, right? Because r is 0, and this is row, this is column. So what value is at row 0, column 0? Well, that is the value of 5. So sum plus 5, 0 plus 5 is 5. So sum is now 5. All right, it goes to line 5. I loop back up. I go to increment, R is now 1. I go to check the condition, is 1 less than 3, that is true. Because the condition is true, I go to line 4 inside the for loop, and I do sum plus grid RR, which is grid 1, 1, and that is 25. Because that is the value at row 1, column 1. So what is 5 plus 25? That is going to be 30, and I assign that to sum. Awesome. I go to line 4, I finish line 4, I go to line 5, I loop back up, go to the increment, R is now 2. I then go to check the condition, is 2 less than 3, that is true. Because that's true, I go to line 4 inside the for loop, and I do sum plus grid RR. R is 2, so it's grid row 2, column 2, and that is going to be 45. So sum, which is 30, plus 45, that is going to be 75. Okay, I go to line 5, whoops. I loop back up, R is now 3. And I ask, is 3 less than 3? That is false. Because the for loop condition is false, I exit the for loop, go to line 5, and now I finish and go to line 6, and I print sum, which is that value of 75. That is question 50. Make sure you know your 2D arrays. Make sure you know that the first pair of brackets is for the row, the second pair of brackets is for the column, and you should be able to do 2D array questions quite easily knowing that. All right, question 50. Thank you for watching this series on the mini exam, and I hope that this mini exam and my videos helped you pass the TExES 241 certification exam so that you can teach computer science here in TExES. See you around.